Actually, using the environment we've constructed here so far is the topic for this, our third course in this learning path on System-Centered Operations Manager 2016. And it's really the content we're about to talk about here that reminds me a bit of an old quote from a former professor of mine years ago who said that sometimes, and with some things, you have to learn all the aspects of a thing before you can really understand any of them. I say that because in our conversation here, we will linearly be stepping through a very long list of all the different aspects, the different kinds of objects that make up a working ops manager infrastructure. Because the learning process really is a linear process, but I anticipate that it may not be till we get to the very end of this course where everything we've discussed thus far will really snap together into place. If you are just joining us, this is, as I said, the third course here in this learning path, where we started with that introduction, really laying out the framework for all the content that we're working through here. And then that took us into the second course on the installation and configuration of the environment here that we now finally get to use. The title of this course is Monitoring Windows Server 2016 with SCOM, and this very specifically highlights that we will be focusing our attentions here on exactly that, how we deal with the servers, services, and applications that sit on top of a Windows Server 2016 instance. Keeping our conversation framed on exactly that OS and just a couple of the things that can sit on the top, I think will go far in helping you understand what can be kind of some difficult topics here as we work through the different modules in this course. Here in this course, we indeed have the introduction. That's the module you're working with here. We really start this entire conversation with, as I recognize, a topic that I've really punted here to this location, but I've done so very much so on purpose. These management packs, as I've mentioned before, contain the knowledge, the actual behaviors that you are intending to monitor. They also contain some of the thresholds then for when a particular behavior is something worth your attention. I put them here because the use of Operations Manager really starts with the implementation or the importing in of those management packs. And the second then task is to then tune the management packs because whoever wrote that MP did so with a best guess for which kinds of alerts you may be interested in. But a lot of times their best guess is not necessarily what makes sense for you. So the importing in of management packs and then the later tuning them, sometimes by the configuration of overrides, is really your very first step in really even starting the monitoring of those different Windows machines on which we've installed agents. Once we have that firmly in place, and this is a task you want to do really one management pack at a time, it's then that we can go through the more honestly interesting aspects, which has to do with making this data now available to users who need to consume it. So this is creating visualizations like views and dashboards. This is setting up service level tracking, like setting up service level objectives and service level agreements. This is also setting up alerts, subscriptions, and even entering in your own corporate specific knowledge there into the alerts and other items that arrive. All these are designed around presenting that information to the IT pros, the other individuals who will be consuming it, in ways that make sense so they can go about troubleshooting any behaviors that they see on the servers in which they're charged with managing. Not every bit of knowledge exists, though, in the management packs that you can download from Microsoft. If you have ever installed a third-party application, which you have, into that environment, you know that, well, Microsoft can't plan for every possible situation. And so when that's the case, you then need to go about customizing exactly what it is that you're looking to monitor. If you have a custom application, if you have some other service that you've installed that may be designed or created locally, you have need then to create rules and or monitors in their own management packs that you also create to then be able to also take a look at those behaviors and alert when things go wrong. And so the last really third of our topics here goes into the customization, the early customization then of that Ops Manager experience, starting with the customization of rules and monitors, and continuing into and really concluding into what I've termed before the capstone here, which is the configuration of distributed applications. So this is our course here, really taking the entirety of what we've built here so far, the servers that we've configured back on that last course, and also the servers that we built as the object then of our monitoring. Now, if you are just following along, everything that we built there in that previous course there on installing, we will continue to use here in this course. That begins with a DC, a domain controller, a SQL server, and our management server there, MGMT. It's that MGMT server that contains really the operations manager, the core of Ops Manager. We also built 3 servers there, which we didn't spend much time in that last course looking at, but we will spend quite a bit more time here actually digging deep into the different metrics that exist there on those machines. These make up our example remote desktop services environment of 3 machines, so a web server, a session host, and a connection broker. These 3 machines are where we'll really point a lot of our monitoring towards to really get a feel for the kinds of behaviors that happen as users then interact with the applications on that RDS infrastructure. And then out of all of these, we have my desktop, that Windows 10 machine, which is where we'll actually do pretty much all the management of this entire environment and where we'll be hosting that Operations Manager console. Your exploration into which MPs make sense for your environment. Here in this module, we'll talk about the whole process of locating, downloading, importing in management packs, taking a look at how their dependencies lay out, and then really how you create your own management pack. So how you would go about the couple-of-click process to create an empty location where you can store your own custom configurations. Here in this module, we'll start by taking a look at a newer feature titled View Updates and Recommendations. It's here where the Operations Manager console itself can highlight which of the MPs that you've currently downloaded perhaps have an update or a suggested replacement, newer version, for example, that's been made available by Microsoft through its Catalog web service. This is a great place to get started for those MPs that were installed as part of the original installation, so those that kind of come there on the DVD ISO media. But they aren't necessarily all the MPs that you need. A large portion of trying to figure out exactly what this Ops Manager infrastructure will do is in figuring out what management packs actually exist to contribute that knowledge to the different services and applications there in your environment. This can be Microsoft management packs, or it can be management packs from other companies as well. We also, while we're there, want to talk about dependencies between MPs. As you might imagine, MPs can rely on other MPs. It really doesn't make any sense for an MP to include monitors or rules or other items that already exist in some other MP. So as you go through downloading these management packs, you have to figure out exactly what the dependencies are between one and another. Now, most often for the Microsoft management packs, this is done more or less for you because they all come from a single company. But it does get just a bit more difficult when you start integrating in those third-party MPs from other companies that may then rely on other companies for their MP content. We will then go through the downloading of management packs, really actually getting them down from the internet here into this local environment, the then importing of those management packs into the environment, and then lastly, that creation of an empty MP. We will do this at this point because later on in that next module, when we start talking about overrides and the tuning of these MPs, there has to be some place for that content to go. The management packs we'll be dealing with here, those we download from Microsoft, are what we term sealed management packs. The idea being that although you can take a look at the content, you can't change the content in that MP. And so when you do need to create an override or do your own custom configuration of a rule or monitor, there has to be an unsealed management pack in which you can then store those configurations. And so we'll start that process with just the couple of clicks we need to create an empty MP in which we'll later then store our overrides. Ops Manager itself. Those actually exist right here. So if I sort by name, you can see the MPs that are currently here in the environment and more or less get a feel for what they're attempting to do. These are kind of the core MPs that contain really the very basics of the very limited amount of monitoring we've seen here so far. A lot of it has to do with the functions that exist here in the console, as well as also monitoring Operations Manager itself. You can see several different management packs here that have to do with the health of your Operations Manager infrastructure. Now you may wonder here at this point why we have such little monitoring initially available here in this environment. This is done really on purpose. One thing you'll find as you're dealing with these management packs is that it is a best practice to go about implementing new management packs on a case-by-case basis, one at a time, so that you have the opportunity to tune the results of that management pack after you complete the import. If you go through and install a new MP for DNS and Active Directory and remote desktop services and all the different things that you have in that environment all at once, you may find yourself very quickly inundated by all the new monitoring that exists over here under the monitoring tab and all these alerts that require your extra effort there in tuning. So if there's any one thing that you may want to pay careful attention here too, is that as we go through the implementation of these MPs, it is a really good idea to do so one MP at a time. I will start our discussion here with the updates and recommendations view right here, where we can see the MPs, so that the core MPs that exist here as part of this default installation. These are separated out here because these are the very core of the things that now our ops infrastructure or SCOM infrastructure can monitor. And they're also the kinds of MPs that exist there on Microsoft's website. Obviously, we are inventorying them from the website through this view here, so that we can see when there are updates that are available. So our core OS management pack, where everything starts from, has an update available. The last update time here was sometime in July. And the process to then grab that management pack is simply to right-click on it and view the options that exist here. So what is the web page where this MP is located at? Is there any further information about the MP? Do I want to take a look then at the guide or get the management pack itself? All of these, it's really a great idea to begin this process by updating these core MPs first, because it is these on which most of the later than management packs will start their lives from. So I want to direct our attention here in terms of just understanding that these updates and recommendations are a great place to go. And it's really a great idea to start the process by actually importing in all these as the very first step here in the process. I will go through this process now to get these management packs and then install them here so that you don't necessarily have to see the import process until a bit later on as we get into the importing of other management packs. Now that process to download and import in all the recommended management packs took about 10 or 12 minutes to complete. All I really did here was click the Get All MPs action right here and allowed it to complete all the processes. One thing you'll notice though, as we're getting into actually getting a feel for what management packs now need to exist on this machine, we start to shift from the updates and then over to the recommendations. You can see here that we actually have, now that I've gone through refreshing this, 4 new MPs that are suggested MPs based off of what the system currently sees that's within its scope of monitoring. You can see here that we now have a SQL Server 2016 analysis services and then also a reporting services MP that is currently set as partially installed. That's kind of confusing. The reality here is that it is partially installed, if I take a look at more information, because some of the management packs that it requires are installed, but not all of those are actually here on this system. Down here you can see those that are already installed and then those that are required in order to be able to monitor that workload. And so we have need now to then download SQL Server 2016 and all these other MPs in order to be able to then monitor this workload with the core SQL Server 2016 management pack. This should highlight to you, as well as right over here, the DTC 2016 MP, this should highlight to you that this whole updates and recommendations node is a great starting point for trying to figure out exactly what MPs need to be updated and which ones are perhaps recommended by the discoveries that have been configured here in the system. Right here you can see that DTC 2016 is recommended because the workloads that it monitors have been discovered there in the below machines, so these 5 machines down here. So we have a bit of a starting point here to help us create that closed set of MPs that will monitor the behaviors we're looking for based off of what now our environment has seen on those machines where agents have been deployed. We can now go through here to the management pack view here and then now choose to download those MPs, the ones that we require. But it's here where perhaps this may not necessarily be the right place to download and then later import these MPs. And I'm not saying that this really cool interface here isn't what you might find yourself actually using, but perhaps it's not the first place where you might go in order to grab the MPs. Right here to download these MPs, we would just add them and then go through the download list here. But rather, I just want to show you that in addition to this very integrated process, the process of actually finding what MPs you require may require a little bit of sleuthing around on the rest of the internet. Let me bring up a copy here of Edge where I've really just Googled for where are the Server 2016 management packs. And I found a great TechNet article here from this System Center blog that shows a list of the current 2016 oriented MPs that are currently out and about in the world. You can see here that we have our Windows Server 2016 and those for, I don't know, clustering and DNS and host integration server and so on. And right down here, I have this RDS MP that obviously we're going to need to import here at some point. Let me click the link here to open this up in a new tab so I can show you what exactly this looks like then. This is the download center for Microsoft. And if I come down here, you can see then the details and all the usual stuff I'm used to seeing anytime I'm downloading anything really from Microsoft's website. I direct you here, again, not necessarily for every MP you download, but for those as you're starting out, it's a great place to go because it's here where you're going to find the MP content, but also sometimes additional content that may not be captured by that neat integrated solution I showed you a second ago. This management pack doesn't have any extra content, so this isn't really a great example, but I can show you right down here that all these different language variants of that MP then highlight right here the US English version, which is the actual management pack content itself. One further item that's associated with these MPs that may not necessarily come down as part of the automated download is right down here at the bottom. This is the actual MP guide for remote desktop services. I have already downloaded these here to this local machine, and you can see that I now have an MSI file and then the guide that tells me really what this whole MP is about to start to monitor here once I install it into my Ops Manager infrastructure. I direct you here because it's the contents here inside this document where you're really going to get really information about what this MP intends to then monitor. So what sorts of behaviors, what down here, what discoveries are going to be created, which classes will be created, your health roll-ups, and also some views and other items that will exist there in the monitoring pane after the MP is installed and processed. And in fact, if I come down here, again, each one of these is going to be a little bit different. This contains more details here about what you will then ultimately find as you start tuning this MP later on. So we'll spend just a bit more time here with the tuning activity there in the module coming up. But definitely as you begin this process, it's a great idea to actually then download these MPs from their original location, perhaps instead of directly there through the interface, so you can get access to any of the extra content or the document content that exists. I will tell you also that if you do that separate download, these come down as a .msi file that actually requires an installation onto a machine. One thing you'll notice here is that as I'm going through this installation, it will copy it into this Program Files System Center Management Packs location. And this is actually an install here onto this desktop. Although perhaps it being an install, it's not really an application install so much as actually just getting that content then copied into that location. So here is that location that we were taking a look at there under C, if I can just scroll over here to the left, there under C, Program Files x86 and System Center Management Packs. All the ones that you download from Microsoft will end up in this location on the desktop where you've completed the download. And it's really right here where you'll see the two MP files that will later need to be imported into your interface. I will keep these here because later on as we get into the import, these are the files that contain that content that is the knowledge being added as part of this management pack. While we're here also, it's worth mentioning that obviously Microsoft is not the only company that provides management packs here for Operations Manager. There are other third-party companies as well. And really the process of finding out which companies exist out there at this point sometimes also requires a bit of sleuthing around using your favorite browser and also your favorite search engine. I'm over here in Google, and let's say I have, for example, a Hyper-V environment or some sort of virtualization environment, and I want to manage that environment and specifically perhaps the backups aspect of the environment. I know, for example, that there's a third-party company out here called Veeam that itself has a management pack that works with Operations Manager. And so if I start sleuthing around here to find the Veeam management pack for System Center, it's here where I can find Veeam's web page where their MP files can be downloaded and later imported. We won't go through the process here of trying to integrate any of these third-party MPs, but recognize that in your environment, you are very likely going to have other products that may have management packs that are compatible here with System Center Operations Manager. So I provide this here as an example. Depending on what actually exists in your environment, you'll have some effort in trying to figure out what MPs are actually available. Now that I've downloaded that RDS management pack, let's go through the process now of importing it in here into the operations console. And I want to go through both examples. So using the downloaded MP, as well as also using the integrated solution like what we can see here. So we will start by then importing in that RDS management pack that we just downloaded, and then we'll continue by adding in another example MP that can become useful here, like for Active Directory. Let's start that process then by going back to management packs and then importing in ones that we have. Here is the import list where we can add in that RDS management pack that we've downloaded here either from the catalog or, like we did just a second ago, there onto the local disk. Notice here that, as before, this MP may have other dependencies that we may not necessarily be aware of, and whether or not we'd like to then search the online catalog so that those dependencies can also be downloaded right here inside of the interface. I will choose yes so that we can then connect to the service and then locate here where we actually have that MP, which is right here in this location. Well, let me paste that in right over here, and then I want to download in both of these two, so the remote desktop services and the library MP right here to the interface. Once I've done that, you can see both of them exist here. They're both successful, and I can now go through the installation for either of these. If I wanted to take a look at the characteristics of this MP, I could do so here, and also take a look at which other management pack this MP depends on. So this will actually help us identify which other MPs contain information required here by either of these two MPs. So let me install it here. It's going through the import process now, and we'll also go through the import process down here for the second one. And if I fast forward things just a second, you'll see that both of these now are imported. We don't have any dependencies that didn't already exist here in this Operations Manager infrastructure, so we didn't need to then download further MPs using that catalog service. I will choose close down here to close it down, and this actually completes getting that RDS MP that installed here. And after a period of time, once all the discoveries run and once the monitors are set into place, after several minutes, we'll start to see new information showing up here in our monitoring view. While we're here, though, let's go through another installation, another MP install for a service that also happens to exist here in our infrastructure. I know this goes counter to what I explained before about downloading them one at a time and doing the tuning one at a time. You will absolutely want to do that when you're running this in production, but here for our lab environment, let's go through the second installation of an Active Directory management pack so that we have just more information that we can then later tune. I also want to use this opportunity to then show you the download process here in downloading and then adding in that necessary management pack. So here, if I go to the download list, I have a very different screen that appears where I can take a look at what's really all management packs that exist there in the catalog, those that have been released relatively recently, or any updates that exist as well. If I hit the search button here, this is where it will give me the very long list of all the MPs that exist in Microsoft's catalog. And you'll notice here, if I start digging down, there are actually quite a few MPs that exist here in the list. If I go here into Windows Server, for example, hey, there's Active Directory Certification Services, and right there is Active Directory Domain Services 2016. I wanted to show you this actually last, after the whole process of searching for them there using your favorite search engine, because although this was relatively easy to find, some of the MPs are actually sometimes difficult to locate here in the list. This is indeed what we need for Active Directory Domain Services 2016, and if I hit the Add button, that will add them here into this list. But sometimes it's not entirely obvious which MPs are exactly appropriate for the types of monitoring you require. And I'll leave it to you to dig around and figure out exactly what I mean here in terms of the long list of MPs that exist. But just recognize that really the best place to start is often not necessarily using this interface. I will choose OK to then download and continue the process of then importing in these Active Directory management packs. They will come here into the desktop location, so there's my desktop location where they will exist. And then after they're downloaded, I should be able to then see them just like I saw the ones a second ago. Here are the MP 1, 2, 3, and 4 that we've just downloaded. Generally, when you do download these management packs, it's usually a best practice to put them in a single storage location that you can later reference if you need to rebuild the system or really get a feel for which MPs you have independently downloaded. So let's actually create that location back over here in our earlier place here in the System Center Management Packs folder. I will choose New here and create a new folder, and we'll call this Active Directory 2016. It's in that location where I will store all 4 of these MPs that I've just downloaded. You'll want to put this in a location because you will later perhaps need to identify it or make use of it again if you end up needing to rebuild the system. So let's do this for all the items and make them available here. The last step in this process is exactly the same as what we did just a second ago in then importing those management packs. Let's take a look at those that are now available here from the disk. And I'll choose yes once again, and then go back one folder and to my Active Directory 2016 folder here. These four, if there are any dependencies, they will be identified down here. If I choose install and then allow this to complete the install, this goes through now installing this other set of MPs that relate to ADDS. Now, all the MPs we've been dealing with here so far are what we term sealed management packs. Those that have been specifically sealed, there's a command line tool I can show you later on that actually prevents them from being altered. You can, as I said, still view the contents, and we will take a look at the contents in the module coming up. But these sealed MPs are designed to be static representations of all those behaviors that we want to monitor. Now, later on, as we get into the tuning for each of these management packs, we have to have some location then to store our custom configurations and our overrides. That happens through another management pack. And if I come down here and close this import management packs view here, I can go about actually creating my own MPs to contain whatever information I require. Let us now create a management pack that we will use for the storage of any overrides or other customizations associated with those RDS MPs, the sealed RDS MPs that we just downloaded a second ago. Let's call this RDS Management Pack Customizations here, and I'll copy that down into this description so I have information there. And if I want, I can also enter further knowledge into this MP as I create it. This will identify the company-specific or environment-specific knowledge that you want to relate then to the MP that you're creating. So perhaps information about what overrides you're adding there into the MP. I don't necessarily need to add anything here, but I can do so by hitting the edit button. And really all I have to do now is to create the management pack here. That is really all that we're going to focus on at this phase of the game. It's later on as we get into then tuning those MPs that will actually make use of the MP that we created here. But just recognize that as you go about then creating these management packs, if I can change the view here, when you go about creating them, it's usually a good idea to have a relatively good naming structure for how you go about creating your own unsealed management packs here. So putting them in perhaps in alphabetical order so that you can easily identify them is generally a good idea. As you can see here, even with just this basic installation, we already have 143 that we have to manage. So having a good naming structure for those that are specific to your customizations is going to be really helpful later on as you need to go find out what you may have changed at some point in the past. In reality, the process of locating and importing and management packs is more a management exercise than in it a really heavy technical exercise. Most of the work here is involved in actually figuring out which MPs you require, and then which MPs those MPs require. So what have we talked about in this module? We've gone through really the steps you'll probably find yourself going through as you begin to then roll these MPs then into production. We started with that updates and recommendations view there, which especially at first is a great place to ensure that you have all the necessary core MPs updated to their proper and most recent version before you start locating any other MPs you want to download. From there, we talked about the many ways in which you can locate them, and which also includes actually searching for them out there on the web. We looked at the dependencies and how each MP can be dependent on others, and then went through the downloaded import of management packs, a couple of different ones there for both RDS and Active Directory. We then concluded with the creation, the very simple process to create an MP, an unsealed version that we'll later use for storing our customizations. Coming up next, we then take the MPs that we've now downloaded and imported and go through the slightly more technical process of configuring the overrides and tuning the alerts that could otherwise inundate us with information. In that next module, we'll take a look at the tuning wizard for actually figuring out which alerts we don't care about, as well as the somewhat complex process of configuring overrides when we want to adjust when our state moves from green to red. That conversation on the tuning of our management packs and the configuring of overrides is the topic for our next module. Coming up. Job number one with any new management pack involves tuning, which is a fairly extended process whereby, number one, you figure out exactly what's in that management pack, and then number two, you figure out what parts of it you don't want. Every new MP, whether it comes from Microsoft or some third party, will have elements baked into it that are perhaps not appropriate for your environment. Maybe the thresholds for certain performance characteristics are set a little too low or too high. Or maybe there are certain alerts or other event logs that are captured that maybe you don't really care about. It's for that reason that, as I said, the very first thing you do anytime you bring in a new management pack involves taking a look at its contents and figuring out exactly what you then want to override. Here in this module, we'll go through the various tasks involved in tuning those management packs, the couple that we've installed here so far. And I want to start this process by really identifying the differences here between the tuning process and the actual everyday process of using Operations Manager and its alerts for troubleshooting different problems. Anytime you're dealing with this tuning activity, you have to also keep in mind that, well, Operations Manager, its whole job is to alert you when things are going wrong. And so I just want to spend a minute or two to highlight some of the initial problems that you can see here with Operations Manager as you're looking there in the monitoring interface. Then, after you've got a feel for exactly what the management pack provides, we then dig into the actual tuning itself, beginning here with a look at the different alerts that MP is generating there in your list of alerts. These days with Operations Manager, there's a great new view that's there inside of the administrative console to help you figure out exactly how many alerts and then which of those alerts you actually want to get rid of. And so I'll show you here where you can just get a feel for how many different alerts are showing up based off of which MPs are generating those alerts. In addition to the rules that exist, there is also the monitors, which is a state-based representation of the health of a particular entity. The process to then either override or disable that monitor is one actually that you can approach from a couple of different directions. I'm going to show you one way here in which, still from the monitoring view, you can then identify monitors that you do perhaps want to tune, maybe to give a different threshold as opposed to what was originally there in the MP, or to disable entirely. You can complete the same task there from the authoring pane, but at least for our purposes here, I think it's easier to visualize if we actually perform these tasks first there from the monitoring pane. And later on when we get into creating our own monitors and rules, it's there where we'll actually start focusing more of our attentions over in that authoring pane. We also want to talk about groups. This is a way in which you can create different groups of objects. So most of the time this is computers, but it can also be other entities as well. We'll talk also about ways in which you can view those configured overrides. Somewhat surprisingly, the process by which you identify which of the monitors you have overridden in the past is something that sometimes is not all that easy to visualize there in the operations console. So I'm going to show you one PowerShell command that you can concatenate together to get a feel for which overrides you may have configured at some point previous to now. We need to talk also about ways in which you can enable monitors using overrides. There are some circumstances in an MP where the MP arrives with certain monitors that are disabled by default. This process is more or less the same as disabling a monitor, and the fact that we actually go and create an override to enable it. But I do just want to show you just a couple of circumstances where you may need to enable a monitor because it is not enabled by default. Now, this entire process becomes much more easy when you have the abilities to visualize the content that exists there in your management packs. And this is also an activity that really isn't well done there inside of the operations console. Thankfully, Microsoft and some third parties have created a website that really does a good job of showing you all the different objects and different monitors and rules and alerts that are generated inside every management pack that you can download. And so for this, our last topic, I want to direct you to a certain website here where you can go about visualizing the contents of the MPs that we've downloaded here so far. Now back over here on my desktop, you can see I've got another copy here of the operations console. I've allowed this to chew for several hours there since the last module so that we can take a look at what kinds of information has been gathered from all these machines where we have agents. And as you can see, we have that veritable fire hose of information that we're getting. We seem to have several warnings here that have to do with Windows Defender. We have also a couple of warnings here that have to do with Active Directory that are also surprising. And so this is kind of an example of where you're going to sit at that very first moment after you go about first installing those new management packs. And again, it's a great idea to do them one at a time so that you don't end up getting this deluge of additional content here in active alerts. Before we get into tuning, though, the MPs that exist, it's obvious that there are going to be some circumstances that actually are problems that exist in the environment that we have here today. Let's take a look at some of the problems that may exist. I see this System Center Management Health Service. It appears to not be running on this machine dc.company.pri. And in fact, if you take a look here at our discovered inventory, we have dc.company.pri with the healthy, it says it's healthy, but the item here, that the check mark, is grayed out. This is a special circumstance here inside of Operations Manager, which identifies that we're not actually getting health-based information from this machine. It indeed says that it's healthy, but it really does not actually have any information it receives to give us an alert on really any other situations that are occurring. It actually is sometimes in these circumstances better to not review things here within the discovered inventory, or even down here under Windows computers, where you can see we have kind of the same situation here with dc.company.pri. I know down here with RDCB, I've got this machine powered off, which is why we're seeing the gray down here for the second computer. But DC, this domain controller, is actually up and running. I think a best starting point here is perhaps not to look at things like Active Directory domain services or remote desktop services or any of the other items that we have here. Rather, it may be better to look at our Operations Manager folder here to get a feel for the actual health of the agent that currently exists here on our machine, dc.company.pri. Let's take a look at the agent health state here, where for the very first time we don't see a grayed out icon, but rather we see a critical icon here that relates to this agent state. This can be a really great place for you to identify when you really don't have a good connection there to the agent on any particular machine. And this particular one, not RDCB, which is powered off at this point, but this machine DC, the reason why this isn't working has to do with actually a configuration change that occurs here in Operations Manager 2016. Let me show you one way in which we can resolve this issue so that we can bring dc.company.pri back online in a much better state. Let me bring up here, in fact, let me go over to my machine DC, the console of that machine, where I'm actually in the Program Files location here under Microsoft Monitoring Agent and then Agent. If I do an ls here, I can take a look at all the content that exists here. This is actually the installed agent on this machine DC. There is an executable here that is part of the agent right up here called hslockdown.exe that is there to help us lock down certain aspects then of the agent's abilities to then interact with the rest of the machine. If I take a look here at hslockdown, let me go down here to the bottom. If I do hslockdown.exe here, I can get a feel for all of the different, actually, make sure I / it first. If I do that here, I can get a feel for the different options that exist. This, if I reference then the /l parameter here, will list all the different accounts and groups that correspond here with the management group name that this agent is attempting to contact. So let's do /hslockdown, and then the management group name being DEN, and then /l to get a feel for those accounts and groups. The installation of the agent here, the Ops Manager agent, requires the use of NT-authority/system for certain activities that are part of the gathering of its information. And right here on this domain controller, again, due to a design decision by Microsoft, this NT-authority/system group is disallowed for interacting here with the agent. And so there are a couple of different ways in which we can resolve the problem. We can install the agent using a domain account and pointing the management server action account there as a domain account, or we can make the change here using hslockdown to allow the agent to make use of NT-authority/system to perform whatever internal activities it requires in gathering all that information. And so let's actually make that change here, /hslockdown.exe, and then from there, DEN. We're looking to then add in an allowed account group, so /a, and then NT-authority/system. If I've done everything correctly, now NT-authority/system is allowed. We still have at least one more activity to accomplish here, and that's to restart the service. So let's do get service here, and I believe it's health service is the service we're looking for, indeed. Let us now stop and then restart this service. Right there by stopping the service, and here once again by starting the service. If I perform this task, this is one way for my domain controllers that here after a few minutes, I should then be able to see these evolve from the critical state back into the healthy state like what you can see here. This will now allow me also to then access all the other bits of the Active Directory management pack that this machine DC then needs to gather information on. So I show you this, number one, so that if you're having problems with your domain controllers, this is one way to fix them. But number two, because this is a great example of actually using Operations Manager to troubleshoot an alert, as opposed to the tuning activities, which we'll accomplish here in just a second. Now that we have this example here of the difference between troubleshooting and tuning, let's get into the actual tuning part here of the rules and monitors that we have. You can see here that now that I've brought that domain controller back online, some of those alert messages about the domain have gone away. I do have another one here that I do need to troubleshoot, but right down here I have a couple of alerts here that just don't seem entirely correct for the environment. I know that I have my Windows Defender scans then configured correctly, and although this is perhaps not one that you would necessarily disable or override, let's use this as an example of a particular alert that maybe we just don't really care about. If I take a look here at the alert, I can right-click here and choose Properties to just see information about the alert. It says here that the alert triggers when the Windows Defender scan is out of date. And right up here under Product Knowledge is where information that Microsoft has written about this particular alert is where you can use to troubleshoot whether or not this actually makes sense for your particular machines. This view is what your Ops Manager users will get to see when they're using it to monitor whatever servers they're responsible for managing. But here also inside of the monitoring interface, for you as an administrator, you also have the abilities to do some overriding right here in this monitoring interface. I introduced this process here inside the monitoring interface, even though in many circumstances you actually do it down here under authoring, because at least at first it is perhaps maybe a little easier to figure out which alerts and monitors you are interested in overriding when you just literally see them here in the list of active alerts. Let us assume, for example, that for this particular alert, we are not interested in seeing it for any of the machines here in this environment. I can get rid of it here by right-clicking on the alert and coming down to Overrides here and choosing one of the two options that exist. Obviously, the first is to disable the monitor entirely, and the second then is to override the monitor, which gives me some further flexibility in terms of what areas of the monitor that I may not necessarily want to disable, but perhaps just change some of the parameters. For this particular monitor, however, let us go through an override. And for these, you can see we have an option for how we target then the override. It is either for this particular object, which in this case is a computer, dc.company.pri, for all the objects there of this class protected endpoint, for a group of objects, which is a topic we'll talk about here in just a second, or also for a specific object of class protected endpoint. I usually like to start here in a specific object of class protected endpoint because it's here where I can see which objects then exist there in that particular class. These are not necessarily, in this case, computer objects, although they are computers in this case. These are objects that exist there as protected endpoints. So if I know that I've got a couple of endpoints here that I do want to override, I can perhaps choose them from the list here. I know in this circumstance, however, that rather than choosing specific objects, what I'm looking for really is all instances of the object. So it's here where I can go through choosing for all objects of class protected endpoint. I will mention down here that you can choose for objects of another class down here. This is a fairly advanced topic, only because typically you don't find yourself overriding objects of other classes all that often. It is the objects within this class, which is what's actually receiving the alert here. So although this exists, you don't find yourself using this last item all that often. Let us go through and override the monitor here for all objects of class protected endpoint. And it's here where we now see the properties of the override we're about to configure. Right here is really the only difference between disabling and overriding this particular monitor or rule, because here we actually get to choose the values then of the monitor or rule in terms of what exists there in the management pack. At this point, we can see we have an alert on state, we have whether or not the alert is auto-resolved when it resolves itself, what the delay time here is, if it generates an alert. And then right down here, we have a couple of interesting values that really have to do with what exactly this particular monitor or rule intends to be actually monitoring. This specific monitor here is actually looking at the configuration of Windows Defender. And so the configuration here is based off of, if I scroll here to the right, the healthy full scan age and quick scan age, which is set here to 7 and 3. If I wanted to, instead of simply disabling this monitor, if I wanted to just change some of the values of the monitor, I could choose to override that particular value and then change the override value to something else, so 14 days or whatever number of days was appropriate. This is the case for any monitor on which you apply an override, so I could change the value here if I wanted to. In this case, however, what I'm looking for is not to change the value. I'm just disinterested in the monitor entirely. And so let's change enabled here from true to false. When I do that, those values then need to be applied into a management pack. So let me make this a little bit smaller here so that I can then view the management pack information down here at the bottom. In fact, let me change some of the taskbar settings here so I can then hide the taskbar when I'm in desktop mode right here. So right down here is the destination management pack here, and these are all the management packs that we've configured here so far. There are some of the default ones that were created as part of that original installation, and right down here is that RDS management pack customizations that we created back in that last module. This is not so much an RDS management pack customization, but rather a Windows Defender, or probably a Windows System management pack customization. So I probably don't want to put that in this management pack, but rather I may want to either create a different management pack or put them in one that already exists. Now, I don't want to go through all that process of creating a new MP to show you once again, so I will set them here in the default management pack just for the purposes of this example. Once I've done this, and once I hit OK here, that completes the creation of this override and disables the monitor here for Windows Defender. Once this process completes, after a period or so, we should then see these alerts then remove themselves from the active alerts view. Now, as I said already, it is entirely possible for us to do this management of overrides from our authoring view down here in the lower left. But at least at first, when we have all the alerts here front and center, it's almost easier just to accomplish those tasks here from the monitoring pane as opposed to digging around into the MPs to actually figure out which monitor you're looking for there in that authoring view. If we take a look here in the authoring view, you can see the list of overrides that right now our scope actually is not correctly scoped to be able to see any of them. So I don't, at this point, really want to talk too much about that other than the fact that they do exist here if I change the scope. Rather, there are some circumstances when I'm going through doing overrides where that ability to override it for a single object or for all the objects in a particular class does not correctly bound that override in a way that makes sense for my needs. If I come back here to an example monitor and choose an override here, recall that I had a couple of options here for a particular object or in selecting some objects, specific objects there in any class that the override is associated with. But sometimes I might need to create a group of objects that is not all the objects in a particular class, like what I see here. When that's the case, I have need to then go into my authoring view and create one or more of these groups. These groups are groups of usually computer objects, but not always, that allow me some flexibility in determining which computer objects I can then do things like assign overrides and disabling monitors for. And you can see here that actually there's quite a few of these groups already. So there's 98 groups here right out of the box. Let us go through and take a look at some of these groups first and then create a group for a set of, I don't know, Windows 10 desktops for which we want to then create a special group. Let's say, for example, that we have our all Windows computers group here. If I right click and choose to view the group members, these should be all the Windows computers that currently exist here, integrated here within this operations manager infrastructure. And there are a variety of other ones here that if you really kind of squint your eyes, you'll notice that all of them, or pretty much all of them, have to do with individual computers, so lists of computers for different purposes. Computers, however, are not the only collections of objects that you can create here with these groups. Right up here, for example, I can take a look at my IIS instance group right here, where if I take a look at the group members, you'll see that the group members aren't actually computers, but rather IIS application pools and server roles. There's an entirely different set of objects here that are collected as this group. So this should give you an idea that, again, although you tend to do these out of computer accounts when you're creating your own, you are by no means limited to just computer accounts when you're creating these groups. Let me right-click and choose to create a new group here, and let me call this, for my DEN site, we'll call this the Windows 10 desktops. And again, I'll put this in the default management pack because I don't feel like creating one for this particular demonstration. I will choose to click Next here, and I have some options now in terms of how I want to identify which objects, which in this case will be computers, should be members of this group that we're creating. I can define them explicitly or I can define them dynamically. In many situations, if not most, it's usually the best idea for you to define them dynamically as opposed to explicitly defining which machines should be in the group. And that has everything to do with just simply knowing that over time, as your environment changes, that the definition of that dynamic group will always update with whatever members should then be in the group. If I did an explicit group here, you'll notice that I can come down here and see all the different objects that could potentially then be added here into the group. One such object I may want to add here is, for example, a computer name. So here under Microsoft.windows.computer, these are the computers here that exist here in my environment. In fact, I've scrolled away so I can't see them anymore. So DC, MGMT, My Desktop, and so on. These are the computer objects that I would want to then add that are here in this full name location, like what you can see here on the right. I don't necessarily want to add in all these machines explicitly though, so I'm actually going to skip this optional part here and create a dynamic inclusion rule for the machines that I do want then to be inside this group that I'm creating. What I need to do then is to create a group of Windows 10 machines. So not Windows computers, but rather, right up here, Windows 10 computers. If I change this to Windows 10 computer here and then add this in, I'm looking for all machines where Windows 10 computer, the value of this is true. I won't add any further operators or properties here, although I could constrain this further if I wanted to particular computers. But let's say all the Windows 10 computers here in the domain that are attached here into Ops Manager, let us add them here into this group. Any computers that I then add into the group, I could add subgroups as well. So these are other groups that will be subgroups of this group. I can also add in excluded members, so those that should be specifically excluded from the group that I'm creating. If I choose Create here, that will go about now creating this new DEN Windows 10 Desktops group that I can use for now configuring an override back there in the monitoring console. One thing you should be aware of when you're creating groups is that sometimes the group creation may not necessarily then gather all the objects that you're looking for. And so it's usually a good idea that once you've done this, to just double check the group. In fact, let me find my DEN group right there. And if I right click and choose to view group members, I should just see one machine there, mydesktop.company.pri. So I am good that this indeed does capture all the Windows 10 desktops that I'm looking for, since there really is that single desktop here in this environment. Let us now complete the process and take a look here at this WMI is unhealthy monitor here. Let us use this as another example of a monitor whose results we just don't care about here in the Active Alerts view. And so I can right-click here and once again choose to override, but let's disable the monitor here for a group and then select the group that we just created. So DEN Windows 10 Desktops right there. Once I've done that, this, as you can see here, disables that group. And if I once again come through here and hide the taskbar so I can see the last part of this screen, I can hit OK here to apply this change here, disabling this monitor. And after a second or so, also then disabling the alert that exists there in the Active Alerts view. So this will disappear here after Ops Manager has a minute or so to figure out the change that we've actually made and then represent it here in the console. Now that we understand the ways in which we can disable or override a monitor, one of the further things we might want to do is just to disable the alerts themselves. And rather than actually coming through here, this list can actually get really long if we have a lot of machines with a lot of management packs. Microsoft has actually added in another really cool tool that we can see down here under Administration for tuning the management packs that exist here, the alerts coming out of those management packs. There is just a bit of a quirkiness here with the way this works, especially in the beginning, right during the initial installation and for the first month or so of operations of this Ops Manager infrastructure. Right here, one of the first things I want to do is identify the management packs that I then want to tune. So in this case, you'll see I've got about, 3 months or so of alerts that I then want to take a look at, and then I want to set the minimum number of alerts for which I then want to display in the resulting screen like what we would see here. We haven't actually had this infrastructure in place for 30 days at this point, so you won't actually get any response here if you just hit the OK button. Rather, it's a good idea to reduce this down to just a day or so you can see the total number of alerts that have occurred over perhaps the last day. This says that we have under System Center Core Monitoring, 26 alerts, and 10 down here under Ops Manager Infrastructure Monitoring, and so on. This is great because for any of these, I can right-click any and then choose to tune the alerts for this particular monitor to now get a better feel for which of these alerts and which of the corresponding monitors that I then want to right-click again and configure an override on that particular monitor. So this is just another way for you to figure out exactly which of these alerts you want to get rid of based off of how noisy that alert is there inside of your alerts view. Now, the curious thing about overrides is that once you've configured them, they can sometimes be very difficult to then locate if you've moved on to something else. If you know that you've configured an override on a monitor, it's usually fairly easy here to right-click on that monitor, go down to Overrides, and then choose the summary to take a look at those that have been associated here for the monitor or for objects of that class. So here is an override that's been associated with this particular monitor. But whereas this is easy if you know where the override was attached, it can sometimes be difficult if you don't know where that override actually is. There are a couple of different ways in which you can enumerate the overrides that exist in an Ops Manager infrastructure. And they range from the somewhat ridiculous but very programmatic to the very static but pretty easy to generate. I'll show you a couple of different ways here, starting first under the Authoring tab. We will talk, as I said, more about the Authoring tab coming up, but it's right here under the Authoring tab where, in addition to all the other things, you can see the overrides that have been configured. First and foremost with these, you do want to make sure that you check your scope so that you do have the correct checkboxes selected for which of the management packs and targets where you may have assigned this override. There are here a list of common targets that exist and a very much larger list of all the targets, some almost 1,500 total targets that can exist where an override could potentially be associated. Let's just take a look at the common targets here because those are the ones where we're likely to see the overrides that we've configured. And those are generally here under your monitors or your rules. Down here, if I start scrolling down, gosh, there's a lot of places where I can find individual overrides that have been configured. Now, right here under Protected Endpoint is the override that we configured before. That's that Windows Defender Scan monitor. But as you might imagine, as this environment starts getting larger and as you start creating more overrides, this whole browsing around inside this list can sometimes be difficult to find the one you're looking for. So let me show you a slightly more ridiculous way here using Windows PowerShell, and then a much easier way using reporting, the reporting node down here on the lower left. I'll start here with Windows PowerShell. Let me bring up Administrator. And mostly I just kind of want to geek out here with some PowerShell commandlets that are pretty cool to work with. Let's enter into a PS session here onto MGMT. And then from there, let's first take a look at the management pack that contains our overrides. So that's Get SCOM Management Pack right here, not Management Group, but Management Pack. Out of those management packs, we are looking specifically for the default management pack. So that's the one that I stored these overrides here in order to cheat instead of creating my own override. If I filter here where the sealed, that's the left column over here, the sealed management packs, where that is equal to false, this will show me those unsealed management packs where overrides could potentially be located. I know that I stored some here in this default management pack, so I can then constrain myself here by where display name is equal to the default management pack here. So this constrains me to just the default management pack. This is where I know my overrides exist. Let me then store that into a variable. So let's call this $MP out of what I just configured there. And with that, I want to get the overrides out of this management pack. I can do that with $MP.getOverrides. This function will grab all the overrides out of that management pack and show me the ones in really a not very human-readable format. And in fact, there are a couple of different kinds of overrides in here, some of which I'm not really interested in. So notice here that I've got right here, this is a monitor property override that looks pretty much like the one I'm looking for. There's my Windows Defender Protected Server Anti-Malware Scan Monitor. Here's one that I don't believe I configured. This is a rule configuration override. Up here is another rule configuration override, and there's another monitor property override that has to do with the System Center WMI functional monitor. So this is probably the two kinds of ones that I'm looking for out of the management pack that I have here. There's some extra stuff in there that I'm not interested in. So out of these, let's actually limit ourselves to just the monitor property overrides that exist. Let me do this. So where XML tag then is equal to monitor property override. That should give me just the three that I'm looking for. So let's select the name here to just take a look at the two that I'm interested in. Again, this is the WMI functional monitor and that Windows Defender protected server override that I configured. Out of these, I need to grab out the monitor itself, where the override was applied, which is the context, and then the property that was configured, and then the new value that I've assigned. These are things that we need to do individually for these. So let's actually take a look at how I can gather some of this information. Let's take this resulting information here. Let me get rid of the select name piece and then pipe that into a variable as well. So the overrides, $overrides, that I'm looking for is equal to that object that I just created. I can now use this to extract out the necessary information. So $overrides.monitor, for example. That is the information there about the monitor, but gosh, that's still not in really useful format. So let me get the elements out of that and see what elements exist. Hey, there is whether it's enabled and then the display name for that override, or really for both of those overrides. That gets me the first piece of information. What I need next is the context. So $overrides.context could give me essentially where that override has been configured. Again, not terribly useful information here, so let's get the element once again and see, hey, there's the display name, so where this was targeted, and also the management pack name, where the original location of that monitor was located. So I could use this now to get the element and grab the display name and also the management pack name if I wanted to. Management pack name there. This is another piece of information that's useful to me. I also want to grab the property and the value information. So property there, which was the property that was changed, and then the value, which is the value that I configured it with, not that, but value. So you can see here that for these two monitor properties, I've configured the value of false, effectively to disable the monitor as part of this override. I can take all this together, and with all apologies for using right host here, I can take all of these together, and if I copy and paste this from the other side of the screen, I can show you that all this information can be concatenated together into a nice report that you may not want to use right host for, but you could use some other PowerShell command to put it in a more usable format to gather all this information from the Operations Manager default user management pack, the WMI Health monitor that we configured, the property here of enabled, and the fact that we've set that here to false, and then target it to our Denver Windows 10 desktops here. So I know this is kind of ridiculous, but it does give you an idea of how you can use Windows PowerShell here to extract out some of the override information if you want to create yourself a nice report. It's worth mentioning too that if you don't feel like going through all this detail, there is a generic report that is available back here in the Operations console, right down here under Reporting. Right here under the generic report library is an overrides report that you can open that report here and then set some of the properties here for the generation of the report. Let me set this from yesterday to today, and then I'm looking for the overrides that are only there in my default management pack, so the same location where I stored those overrides in the first place. Do I care about sealed ones? I do want to exclude those, and here are the criteria here as well. So again, if you're not interested in Windows PowerShell, this report is one way in which we can again see there is our WMI Health monitor, and there's our Windows Defender Scan monitor, and effectively this is the content that exists there in that default management pack. We're not quite done yet also, because as we're looking at the Health Explorer view for our different machines, sometimes you might find that there's a machine and a Health Explorer little dot that actually does not appear to have the green check or the red bad X associated with it. Let me show you an example of that here under monitoring. Let's take a look at our machine RDS Web here. So here under our discovered inventory, let's see RDS Web right here and actually view the Health Explorer for this machine. You can see here that we have no problems here with the machine, but if I unfilter the monitors and take a look at all the available monitors, if I start scrolling down, I may notice something very interesting. Well, look here. Under my operating system performance roll-up right there, and under performance is, hey, there are a couple of monitors here. There's one there and one there. There's even some right here. that do not have that green check associated. What this means is that in the original management pack where these were configured, the management pack by default has not enabled these monitors. Sometimes this is done because enabling the monitor has a performance hit on the system, and there can be a myriad of reasons why these aren't enabled by default. Many times for performance reasons or for data collection, just an amount of data collection reasons. But if you do have need to actually enable this monitor, the way in which you enable them involves using the same kinds of overrides that you would do for disabling the monitor. Let's go through the process now of actually enabling this monitor, this percentage of committed memory in use for this particular system. I can actually do so right here by right-clicking and choosing the monitor properties here. This view gives me a lot of detail about what is actually being captured by this monitor. So it tells me that I'm doing percentage of committed memory in use. This is the percent committed bytes in use perfmon value that it's looking at. The specific performance counters right here under the memory object. We'll be spending more time in actually configuring these as we get into configuring our own rules and monitors later on. You'll notice that these are all grayed out here because these are part of an already existing sealed management pack. So I can't make any changes here to any of the other configurations like the threshold comparison or the health configuration here or the alerting configuration. Any of this is all off limits because this is one of Microsoft's sealed management packs. One of the places though where I can make changes is back here under overrides. Let us now actually enable this monitor because it is disabled by default, and we'll do so for just this object. So Windows Server 2016 Data Center, any of the machines that are there in that object. Let me do that, and then right down here you can see that under enabled, the enabled value is set here to false, which means it is not enabled by default. Once I've set this from false to true and set the management pack down here back again to my default management pack, and if I can scroll this down very quickly again, or actually go back down here and then cause the taskbar to go down, you'll see once again that I can enable this. And after a second or so, once again, Operations Manager does all its background work, this override will now allow Ops Manager to begin making use of this particular monitor right here. And after a couple of minutes, we should see this green circle then populate with a green check or also maybe a red X. It is worth mentioning also that while you're going through the overriding of any of these particular monitors, sometimes it can be useful to come here under overrides and not only disable the monitor, but also change some of the values. Down here you can see that the threshold value is 80% for this particular monitor. And if I wanted to change it from perhaps not 80 to instead 95% as the new value, I could do so as I'm making the changes here inside the override. So again, this mostly is here just to show you that the process to enable a monitor is more or less the same thing as the process to disable a monitor. It's here your overrides tab where all this work actually happens. Now, one final topic here is involved with the visualization of all the content that exists here for these management packs. And for this, I want to direct our attentions away from the Ops Manager console itself and instead over here to a web page. This web page is the systemcenter.wiki web page that provides some really good visualizations for the different kinds of MPs that you probably have in your Ops Manager infrastructure. Let's take a look here at actually the Windows Defender management pack way down here at the bottom. This is the one that we just enumerated just a second ago. And if I find it right here, you'll see that for Windows Defender, we can see the various elements that exist there that are all baked into the sealed management pack. So there are 3 discoveries here. There are 6 unit monitors and 2 aggregate monitors. And the actual content I can find here by clicking down here on the link. So right here, if I look at, let's see here, the active malware monitor, this is the actual monitor that exists here with all the knowledge base information, the element properties, and the original source code that Operations Manager is actually using for figuring out whether or not Defender is appropriately configured. So I don't want to spend much time here because it's worth more of you kind of poking around here on this website to see the contents of your MPs. But I do want to direct your attention here to systemcenter.wiki as a great resource for helping you figure out why some of your monitors are alerting you in the ways that they are. The tuning process for any new management pack really is what separates you from you getting a lot of phone calls about pagers going off far too often. Anytime you're going about adding a new management pack, there really is that process of figuring out which of its alerts and monitors really do make sense for your particular implementation. What have we talked about here in this module? We have gone through that process of tuning those management packs, mostly through the use of overrides. We started first by separating out the actual task of troubleshooting your systems from the tuning process itself. I showed you an example here of how we can use the information that Ops Manager provides to try to figure out why the alert is occurring. In some circumstances, there actually is a change that's required on a monitored system. From there, we moved into tuning the management pack alerts, so actually taking a look at which alerts we're seeing and using that as the starting point for configuring overrides or disabling monitors entirely. In certain circumstances, the overrides that you're configuring can be assisted through the use of a group. Maybe you don't want every machine, but only certain machines to have the override applied, and so creating these groups is a great way to limit the targeting for any configuration changes you're making. We also took a look at the various ways in which you can then see those overrides after you've configured them, all the way from the ridiculous Windows PowerShell way through to the very easy report that's generated there in the reporting interface. We also looked at how enabling a monitor is possible, also using an override, and took a look there at the systemcenter.wiki site, which presents the opportunity to visualize the contents of those management packs as you try to figure out which behaviors are being alerted and why. Coming up next, we take this environment that we have now presumably tuned and then make it available, the information inside available to everyone else that's working with our servers and in our data center. In the next module, we'll talk about how to customize views and dashboards to present relevant information to people who require it. We'll take a look at some of the different kinds of dashboards and dashboard elements that exist, as well as a few special purpose dashboards and views that can deal with both servers and services as well as networking to provide better information for those that are managing your servers and services. That conversation on customizing our views and dashboards in Operations Manager is a topic for our next module coming up. Next up in our Ops Manager exploration is visualization, the process by which we go about slicing and dicing this fire hose of information into the views and dashboards that make it ultimately usable, consumable by the other IT administrators who require it. Our module here has what might seem like a large amount of content, but rather what I've done here is try to provide a couple of useful use cases for how you might go about creating the dashboards that you probably might want. As is obvious, the number of ways in which you can create views and dashboards are virtually unlimited and has a lot to do with exactly the requirements that your different IT admins are going to lay upon you for what information that they require. And so it's difficult for me to create a closed set here of all the possible views that you could create, but rather let's focus our attentions on exactly just a couple of those use cases here. We'll start by taking a look at the default views that exist in the management packs that we've already imported here into the environment. So these are the views that are in those MPs. And as you'll find, they really aren't all that malleable. Although you can personalize the view, you can't really do much in terms of adjusting the properties of the view. With that, we'll then take a look at a couple of network monitoring dashboards, some special use dashboards that are there right out of the box. These network monitoring dashboards are ones that arrive during the initial installation here of Ops Manager, and they can become useful if you've gone through that step of creating those network discoveries like what we discussed back in the last course. We have, and I know I've sort of alluded all the way here to this point here in the learning path, have had the need for defining an up-down monitoring view for the different computers here in the environment. We have in this environment that machine, that RD connection broker machine, that has essentially been powered down throughout the entirety of this learning path here so far. And in doing so, we've noticed that, the icon for that computer is grayed out as opposed to being a big red angry X. I have obviously left that here to this point on purpose because it's here where we can take a look at a way in which we can now create a state-based view for the machines that are down. That state-based up-down monitoring view is one that can be useful if you just want to have a good heads-up display for which machines are actually not powered on. It also can become a location that we can use for defining the alerts that we'll later configure in the modules coming up. So this is kind of the starting point for one of the custom views outside what you would have there in the default management packs for how you might create your own custom configurations for users and their requirements. We'll talk a bit about how you can declutter the monitoring pane. You actually can just simply remove some of the folders that exist there. And then we'll take that up-down monitoring pane and scope it to just our remote desktop servers. In your environment, you may not necessarily want all the IT admins to get access to all of the alerts. And so it's here in this portion where we get a feel for how to scope down which content ends up in the view so that we don't need to provide total access to every administrator. In creating the views, we may also want to add tasks into those views, which give that administrator the abilities to perform certain activities there as they see some issue that exists there in the view. This process requires us to know which command line or script we need to run whenever the user clicks that actual link. So we'll talk here about a way in which we can add tasks into the different views that we're custom creating here. Now, once we get a feel then for the views, we will then expand our focus into the collections of views that we think of as dashboards. Each dashboard will have one or more widgets associated with the dashboard, and each widget will then effectively map to the views that we created before. There are actually a larger number of dashboard widgets than are there different kinds of views we can create. And so we'll take a look here at which kinds of widgets exist and configure a few of them together into a dashboard for our RDS servers as an example of how we might set one of these dashboards up for a particular set of consumers. Lastly then, all those views and dashboards that we create, we probably then want to go about configuring permissions for the users who require them. If our users don't necessarily need to have access to everything, well, it's here where we identify exactly which dashboards, which views, and also which tasks a particular global group of users should be able to access. So back over here on my desktop, I have the operations console right here. And I don't want to spend altogether too much time here going through the default views that exist because you really can poke around there in the interface to see which ones are available there out of the box. But I do just want to show you that all of these views, that most of which we've actually taken a look at here so far, are representative of the different classes of views that you can create. If I right-click really anywhere here under the monitoring pane, I can actually create a new view here that aligns to one of the different view categories that exist. So an alert view, an event view, a state view, and so on. These different views provide you obviously different ways in which you can visualize the data. Whereas an alert view, for example, shows the alerts for a particular group of objects. So this is all the active alerts in the system. And a state view right down here presents the state view for that representation then of this object. These are the distributed applications that exist here that have been configured. Also down here, we have the Linux and Unix machines and the Windows computers that exist here in the environment. Out of all of these, it's perhaps the state views that, at least at first, can generate the most confusion, in part because the state view, the computer object, and then the role objects that, like what we're seeing here, may not necessarily have the same behaviors when the machine goes down from what you may be used to in a monitoring system. I've said it before, this RDCB computer here is one that's more or less been powered off since the beginning of the learning path. And as you can see here, we have a grayed out representation of the green checks associated here with these different state objects. This is to identify that the agent at this point is not providing information to give our ops manager infrastructure any further information about the health of those particular objects. It's here where we have to kind of separate out our notion of the computer from the other representations then of the applications and services and also the agents that exist on that machine. And so I kind of want to highlight here the fact that sometimes these state views can be slightly different than what you might expect because they are then bounded by whatever class and object that that particular state view is pointing towards. Let's take a look, for example, at the properties here of Windows computers so that we can see here how this data can be related to really any of the different classes that exist here in Ops Manager. Right here, we are displaying data related to Windows Computer, and really this is, I guess, the most foundational representation then of that machine. This Windows Computer representation is one of many different targets that can contain information about that machine. And it's here where things kind of get sometimes difficult, especially as you start poking around to try to figure out exactly what content is important to you. Let me then expand this so we can take a look at the content that exists here. These targets right here represent all the different classes that contain information about that particular object. So logical dist information and network adapter information and so on. It is perhaps the easiest to see or visualize what this information is by taking a look at the management pack and also the description, but really the management pack that contains that particular target. And so when we're talking about state views, we can direct these state views to any of the targets that exist here in the list, not just the common targets, but all, at this point, almost 1,500 targets that are out there. Many of these may not at this point have any monitors turned on. For many of these, it may be irrelevant entirely to the object in which we're really looking for. And so, at least at first, it really is a bit of a guess and check process to figure out for yourself which out of all these 1,500 or so targets contain the information that can be valuable for you as you're going about creating these state views, these state views here in the Ops console. We can also do conditions here to scope down which situation we're interested in monitoring, as well as scope it down using groups, which is a process we've talked about already, but I'll actually get a bit more detailed here in just a second. Mainly at this point, I just wanted to show you that out of all of these different objects that exist, the views that are here in monitoring, you have to pay careful attention to what exactly you are monitoring in these different kinds of views. So for example, here in Remote Desktop Services, when we're looking at Remote Desktop Services and perhaps the Remote Desktop Services state, this may not necessarily be the computer object, but rather the Remote Desktop Web Access object that exists here in the class here of Remote Desktop Services. Because of this, we actually get a different set of information. This class contains a very different set of information than that computer object does itself. It's easiest to visualize what these differences are by taking a look at the Health Explorer for any particular object. And in fact, let me start back up here under Windows Computers and take a look then at, for example, rdsweb.company.pri. Well, let's take a look at the Health Explorer once again for this machine and remove all the monitor filtering here so we can see what we have. If I start scrolling down here, you'll notice that because we're focused there on the computer object, well, we have quite a bit of different monitors that relate to the health of that computer object. So our operating system availability rollup that relates to our core Windows servers and our maximum concurrent APIs and so on. These are very different than what we would have if we take a look at how these are scoped down here under RDS. For our Remote Desktop Services state view right here, if I take a look at RDS Web once again, right down here in Health Explorer, you'll see that after I unfilter the monitors, that there is a very different set of information that's being gathered. In fact, there really is only a single monitor like what you can see here. This single monitor is looking for the configuration of RD Web Access, and not all the other bits that make up any generic Windows server. Over here under Knowledge is where you can see the different items that are being looked for in this configuration monitor. So we're looking for event IDs 8 and 10 right here, event ID 4, event ID 6, and so on. These relate to the actual monitors that exist over there in the authoring pane that are looking for this information there out of, in this case, the event log. These monitors and rules in the event log we can then further visualize by taking a look at where they exist there in the authoring pane. Let me show you down here under the authoring pane that if I come here to, for example, monitors, and I scope things here, in fact, I already have it scoped here, under the Remote Desktop Services Licensing Server, Host Role, and Web Access Role Service view here. So this is the class of information we're looking for. Here for this class, we have Entity Health, which exists for all the classes we're looking at. And then sub to that, we have all the different kinds of roll-ups. So the aggregate roll-ups that exist for every single class that we configure here in Ops Manager. You will always see an availability, configuration, performance, and security item here in this second drop-down in the tree. Here under configuration is where you can see that monitor for our RD Web Access configuration. This is the actual monitor that is performing actual work that then translates to what we see back over here in the monitoring pane. It is that monitor that contains the information that lets us know whether or not that web access server is healthy or not. And right down here you can see Remote Desktop Web Access as being the display name with the full path name down here, then correlating to that monitor. And so this is perhaps much more of a review than what you might anticipated for the different views like what you can see here. But this information will become handy as we start going through the further customization of these views, and particularly later on as we get into the creation of our own monitors and rules in translating what you see here into what we'll later configure in the clips and also the modules coming up. While we're here, I want to show you one set of views, really dashboards, that are kind of a special use case here because they are included with Operations Manager right during the install. These are the network monitoring dashboards, and I show you them here only as an example of ones that are created and that you can use here without any further customization. Here under monitoring, if I go down to the network summary dashboard, so right down here under network monitoring, and then right here is one of those dashboards that's created for you right out of the box. If you recall back in that earlier course, when we went through the configuration of our Ops Manager infrastructure, we created a network discovery that then would allow us to identify this machine 3.2, which just so happens to be the default router for this environment. When we created that, we created it as an ICMP discovery as opposed to an SNMP discovery because, well, to be perfectly honest, I don't have an SNMP capable default router here in this environment. In your situation, at least your production situation, when you are connecting it up to your production equipment, it is usually a better idea to use SNMP because SNMP will then populate all the other items that exist over here, such as the nodes with highest CPU usage and highest utilization down here. We can, with ICMP alone, see what our node here is with our slowest response, which, because we only have one node, isn't all that useful here. What I do want to show you, though, is not so much that there's not much here, but rather that there are 3 different network dashboards that can actually be really helpful in helping you troubleshoot some network conditions that exist once you've made those configurations to turn on those discoveries. Here we are in our network summary dashboard, but there are 2 further dashboards that exist once I single-click one of the nodes that exist here in this list. They are my network node dashboard and my network vicinity dashboard. Now, the network node dashboard will provide me information about the individual network node, as well as the vicinity view for that network node as well. For this ICMP-oriented discovery here, again, all we're doing is pinging to see if that particular network device is up. All we really get is our average availability here for today, yesterday, the previous 7 and 30 days. Which, because this router has been on that whole period of time, we have 100% availability for this particular device. Here in the vicinity view, once we set up those SNMP-based discoveries against all these different network devices, we will then later see, once you move into production, you will later see a single hop representation from this device to all the other monitored devices in the environment of exactly what exists there, a single hop away from whatever I've selected here. And you will be able to then adjust what the hops would be. I can also adjust how many hops I want to represent this diagram as being, and whether or not I want to show the computers as well. Again, these don't exist here because we don't have that discovery configured, but this network node dashboard can be really useful. The network vicinity dashboard right down here also provides just a single vicinity view for what we saw there just on the left-hand pane. Also with down here some additional instance details for the access mode, the display name, and the path. So I just wanted to use this as a further example of some of the dashboards and other views that you will see as you start tooling around there in the interface. And the fact also that these network dashboards are just a bit buried there in comparison with the other dashboards that you'll see as you back right down here to our original view right over here. Let's talk now about how we can customize the views that we see here for our purposes in ways that aren't automatically made available through the management packs that we've imported. One of the great requests, one of the major requests that a lot of people have is in creating this up-down dashboard for all the computers in an environment. I don't want to necessarily know that right up here, that the actual, not right there, but right here, that the state view for RDCB is showing as gray. When RDCB is down, I want that to show up as a big red angry X to let me know that there indeed is a problem. You should be aware that although this is right here in gray, the gray represents, as we can see here, the 2 alerts that exist associated with this machine RDCB. So this is the health service heartbeat failure, and then they failed to connect to computer alert like what we can see here. If you take a look at these actually relate to the alert monitor titled Computer Not Reachable, and then right down here is the Health Service Heartbeat Failure. And I'll let you dig further into over on the authoring pane if you want to take a look at what those monitors look like. But either of these can become the source by which we then create a different view that instead of representing those down machines as gray, instead represents them as big red angry X's. Let's continue this process by taking a look at another state view where this actually ends up in red so that we can use that as the basis for our customization. Right down here under Operations Manager, if I find it right here, here under Operations Manager and Agent Details is the Agent Health State view right here. This Agent Health State view, it's really a dashboard, contains information about the agent state that sources from the Health Service Watcher agent group. So right down here, you see Agent Watchers group here. You can see here that when we actually don't successfully respond back to that health service heartbeat, but we end up with a critical view as opposed to a healthy view here. This is actually one way in which we can create that green versus red representation of when a machine is not responding to its health service heartbeat. Essentially, this machine is down or off the network. With that, we now know that we can use this as a source for creating our new view. And so let's actually go through now and create that new view so that we can make it available for any person who has need to determine if machines are up or down. I'll start this process way up here under the monitoring view, because I'm not really ready yet to put it in any of my custom management packs. And so this may not necessarily be the initial approach that you use, but for now, let's put this in our default management pack just so that we have some place to store it. Let us create here a new state view. And for this state view, let's make the configuration to create a new state here called computers up, down, state. In fact, I'm not certain if the dash or the slash works there, so we'll call it up, dash, down, state. Our first step is to identify which data that we want to relate the view towards, which is not going to be the object class here, but rather the class that's associated there with that Health Service Watcher. I need to then type in Health Service Watcher here, and then view all the targets to take a look at all the options that exist. Out of these, we have our Health Service Watcher class here. We also have classes there that are associated with the agent, the collection management server, the gateway management server, and so on. It's right here, this Health Service Watcher agent, that actually ends up being the correct one that we want to scope this view towards to get the information that we require. And you, as I said, you'll have to sort of dig around to figure out which of these classes contains the right information. And yes, that is a bit of a guess and check process, at least at first. Right here, let's take a look at this agent here. Let's use this as the source for the information that we're going to store in the view. And when we do store this information, let's choose a specific health state here as the conditions and actually choose all the different health states. So I don't care if the machine's in any health state. I just want a nice view that shows me whether it's green or red or any of the other health states that exist. Let me choose OK down here. This will now create that view, the computer's up-down state, because I've scoped it to that Health Service Watcher agent class right there. And if I save the view and allow it to go through its internal background processes, this process takes just a second or two to complete. And after Ops Manager completes what it needs to do in the background, we now have our new view here that includes our state view, so critical versus healthy, and then the name and then the path information for these machines. If I don't really want the path information, I can edit this right down here under Properties to change the display information for which columns I want to display, to sort the columns, and also to group the items if I need to. I'll choose Path down here, or unselect Path, to remove the path out of the existing columns, and this now creates a view that can be consumed by anybody that has access here to the operations console, or also even the web-based console as well. This view now shows me for all of these machines. Here's RDCB, my desktop, and so on, and those that are critical versus those that are healthy. I now have that up-down state view that I was looking for helping me know when machines are powered down. Now, as you might imagine, as you go through further customizations, the monitoring pane here can actually get quite a bit cluttered over time. And there are a couple of, let's call them hacks that you can go through to declutter here the monitoring pane if you don't want to have to worry about the objects that end up existing. One such way is right over here. If you recall earlier, we went through and created a management pack there called our RDS Management Pack Customizations that, at least at first, was there to contain all the overrides, the RDS specific overrides. One thing you should know as you're going through decluttering the monitoring pane is that if you find yourself in a situation where you've created a management pack, if you don't plan on adding any views into that MP, if the MP is designed for only containing overrides, you can't actually delete the folder that exists here in the monitoring pane. This will not delete the management pack, nor will it delete the overrides that exist there in that management pack. So this is one way in which you can actually declutter here the monitoring pane by removing any of those MPs, those unsealed MPs that you created that don't or won't create views at any point in the future. It's possible also to use some special trickery here by using perhaps underbars or Z underbar folder name as ways to move them up or down in the list. So this is just another way in which you can then declutter that monitoring pane to shove the stuff you don't want to see to either the bottom and then shove the stuff you do want to see there to the top. For this particular folder, however, even though we didn't include any overrides with it, at least yet, we do need a management pack to contain the views that we will now be creating, the custom RDS specific views that we'll now be creating. So rather than deleting this folder, let's keep the folder around and let's call it something else. Let us call it instead the DEN RDS servers. If you recall, our management group here is the DEN management group. So this will now become the RDS servers here for our DEN management group. Once we've done that, we can now use this folder as the container for storing the overrides, as well as the views and also any groups that we'll be later creating here in this module. For then our next task, let's assume that we have some RDS administrators, a group of them, who have need to understand the health and availability metrics associated with their servers, but don't really care about all the other stuff that's here cluttering up the monitoring view. Or perhaps they don't really need to have access to that information. Let us now use this new folder that we created here, this DEN RDS servers, as the storage location, the MP associated with this folder as that storage container for not only the RDS overrides, but also the view and then the group that we need to use to constrain this view down. I'll start that process down here under administration because one of the first things I want to do here is actually rename the management pack to the folder name that we configured just a second ago. So right here is that RDS management pack customizations MP. Let's just change the name here to DEN RDS servers. You tend not to do this all that much in production because obviously the ID has not evolved. But let me just change this just to make it simple here for the later configurations we're about to make. Once I've now made the change here to this name, the next step in this process is to go about creating a group by which we then use to set a boundary around which machines we want these users to be able to access and then view the monitoring information for. This group will need to contain not only the computer objects, but also the Health Service Watcher Agent class-oriented objects as well, because it's there where we can get the up-down metrics that we need to let those RDS IT admins know when their machines go offline. Let me start here under groups. We've actually been here before and go about creating a new group. Let's do DEN RDS servers here. So this is the group, and we'll set this to our new MP here, DEN RDS servers. Here under next is where I can define either the explicit group members, but I don't necessarily want to hard code in a bunch of servers. I'd rather set it up based on perhaps a naming schema for the different machines that may later then be involved with this RDS infrastructure that they are building. So rather than doing an explicit group, let's do a dynamic inclusion rule here that includes the Windows computer object, and I'll scope that down here by, let's say, NetBIOS computer name, where the computer name matches the wildcard of, say, RD star. All my servers start with RD and then something. Once I've done that, that will give me the information about the computer, but doing so will only give me that grayed out representation if any of these computers go down. To be able to have this up-down monitoring view, in addition to the Windows computer objects, I also need to have the objects that are associated with that Health Service Watcher Agent class as well. So let's go over here and then drop the drop-down list here and go to Health Service Watcher, which is right up here at the top. And here under Health Service Watcher right here is Health Service Watcher Agent, which I'll also add down here to the bottom. One thing I should tell you about this particular class here for Health Service Watcher Agent is that the only way in which we can further constrain which computers end up here in the group is by computer name. There is no way here in the interface to use other mechanisms to define which computers are in the group. There is a way that involves a bunch of XML and exporting, reconfiguring, sealing, and importing in a management pack that's far beyond the complexity like what we can do here that will allow you to do some better defining based off of different dynamic characteristics. I want to just highlight the fact that that is possible, but it's more that we can tackle here in this module here today. For this module, though, we do want to set our display name for the object here to also match the wildcard associated with the RD star item right here. So this will also give me the Health Service Watcher Agent objects that start with the name RD and then a star, so whatever's beyond that. This will, if I've configured everything correctly, create the query formula that will give me 6 different objects, 3 computer objects for my 3 RDS servers, and 3 Health Service Watcher agent objects there for those also associated with the machines once I complete configuring this new group. So let's choose next here. We don't have any subgroups, and we don't want to exclude any objects out of the group. Once I've done that, and once the group then creates, as with all group creation, we want to take a look at the members of the group to make sure that indeed those 6 objects now exist there in the group. It will take Operations Manager just a second or so to complete its background processes. And then once it's done that, I should then be able to identify my new DEN RDS servers group. Let's take a look at the group members here. In this group I have, as it renders, it looks like 6 different objects, 2 each for each of the servers, so RDCB, RDSH, and RDS Web. These are associated with, again, the computer object and the Health Service Watcher agent object here. This now can become the group that I'm about to use for the view I'll create over there back in the monitoring view. So let's close this down and go back to our monitoring view here. Once I've done that, let's scroll back down here to that DEN RDS servers folder. One thing you should be aware of is that anytime you're dealing with any unsealed management packs, those that you haven't exported, sealed, and then brought back in, anytime you're dealing with those, you can't have an unsealed MP or any of its contents be referred to by another unsealed management pack. And so you'll find you can't actually use the contents in one MP in the view of another. It just won't allow you to perform that task. So you'll find that MP as being more or less a closed set as you start generating all this content. The MP will contain the groups, which will contain the views, and all the other information that relates to whatever it is this MP is designed to contain. And so let's now create the view with that in mind, this new state view for just the up-down monitoring for our DEN RDS servers. Let's call this here our DEN RDS servers up-down state. And for that, we'll show the data related to, once again, the Health Service Watcher. So Health Service Watcher here, and specifically the agent class right down here. As before, we get a warning here about changing the target type and not changing the criteria, which we don't have to worry about here. Once again, we do want to change the specific health state to select all the health states that exist. But now we need to then bound the data not just to all the machines in the environment, but rather just to those RDS servers. We do so by selecting a group. Right down here is our DEN RDS servers. And for this, we're only going to use half of the 6 objects that we added there into the group. Recall that we added in computer objects and then Health Service Watcher agent objects. And so it's only those agent objects that we care about in the view we're about to configure. For that, we'll also remove the path just like before. And if I hit OK here and allow the background processes to occur, we should get a new view that just contains those RDS servers that will then later make available to our RDS administrators. And after a second or so, we can see, yep, there it is. Those are the 3 machines, RDCB, RDSH, and RDS Web. So this does now give us a feel for those DEN RDS servers and their up-down state. And in fact, to that end, let me now go and power on RDCB so that we can make use of it here for the rest of the demonstrations. Now, just seeing the health state of the different objects in these views is one thing, but being able to use that information to directly enact change for that particular object is yet another. That actually happens as part of the tasks that exist over here on the right-hand pane, and we've seen these tasks already. They obviously change depending on what kind of object we're looking at, although there are also some objects or some tasks here that remain the same. So these generic tasks here for the entity properties in Health Explorer, the navigation items here for switching around different views that you're looking at. And then down here we have the tasks that are specific to the class and object that we're looking at. These tasks are related, as you can see here, to the Health Service Watcher class, like what we've defined right here. But let's say that you have the need to make some custom tasks and then to add them into the views that you create. For example, let's say our RDS web machine right over here. If there is some situation that goes wrong with the actual web service then on that machine, wouldn't it be great to be able to then start and then stop perhaps the web service? Let's go through it now and create those custom tasks here and make it available then to our RDS machines, but not just to RDS web, really to any machine that happens to also then be a remote desktop web access server. I'll start this process over here under authoring, where we can take a look at the tasks, which are right here. As before, you can see we've got things scoped here just to the couple of RDS-oriented classes that exist here. This is done by changing the scope right over here and then identifying which ones I want to look at. I've just made those changes right here. These here show me that for these different kinds of role services that exist, like our licensing server and host role service, and also our web access role service, that there are some tasks that are going to be associated with each class. These are coming out of, as you can see here, the Health Internal Library Management Pack, so the default MP that exists right there on the system. Right over here, though, for the host role service, take a look at a couple of other tasks that exist, like stopping the remote desktop services service or starting it, enabling logins and querying logins, and so on. All of these are tasks that we will see when we take a look at, frame within that class, so the remote desktop session host role service class, that we'll see over there in our list of tasks over there to the right. And so for us to then be able to make use of these for my RD Web Access server, you'll notice that for RD Web Access, there actually isn't a task here for restarting that IIS service. Let's now go and create two tasks, one to stop and then one to start that IIS service. I'll start here by right-clicking on the role service and choose to create a new task. This is handy because it actually then orients the task or deposits the task into the appropriate location. I'll put that here into my destination management pack right here, DEN RDS servers. And it's here where I want to then configure an agent task. This is not a console task. I'm not doing it on a machine that's running the operations console. I'm doing it way over there on the agent and from the agent's perspective and also using that agent's permissions. So for this, I need to know what the command line will be. Here we'll create a task. Let's call this stop IIS service. And as you can see right down here, this actually targets it, as I said, to that web access role service. So I don't need to then find it there in that very long list of available classes. Here under next is where I need to put the full path to the file. For this, I'll actually be using the net command, so net stop. And if I copy and paste over here from my notes, there is systemroot/system32/net.exe. What we're looking here is the net stop command for w3 svc and /y to confirm what we want to do. For our working directory then, if I copy and paste one more time, that will be systemroot/temp. And let me set in, 60-second timeout here for this particular execution. This obviously is a traditional command line command that we're running, the net command here. If I were to reference PowerShell.exe, its full path to the PowerShell.exe executive, I could then choose as the parameters what I then enter in as a single line command that I execute here. So PowerShell is represented in much the same way like what we can see here with your more traditional command line commands. And so let's create this. So this will be net stop, and then I'll also need to create net start to then start the IIS service once I've completed. That process is effectively the same. In fact, the only difference here is in changing stop service to start service. So let's create a second task here and once again drop it down here in DEN RDS servers here. We will call this start IIS service. Include it there in the task target, so web access role service. And then once again choose the full path to our file, which as before will be in system32 net.exe. Here we're doing start w3 svc/y. And we're once again using the same working directory, so /systemroot and then temp, and adjusting my timeout from 15 to 60 seconds. So this is effectively just reversing what we did just a second ago. We now have two tasks that are scoped now to this web access role service class here. And once they've been configured, we can take a look at where we will actually then visualize them over in our monitoring pane. If I come back here under monitoring and take a look at my server's up-down state, and scroll, wait a minute, I don't actually see the tasks here in the list of those that are available. Remember that we have created here instances of that Health Service Watcher Agent class. These are not actually computer objects, nor are they RDS Web Services objects. These are Health Service Watcher objects, so they won't actually see the tasks that I've configured because I scoped them to an entirely different class. In order to see them, let us create a different view here. For this view, let's create a state view, just like we did before. For the state view, let's call this a DEN RDS Web Access Server Health. This time, however, we'll be changing what we're actually referring to a very different target. For this target, let's do remote desktop and then view all targets to take a look at the remote desktop oriented targets that exist here. So what we're looking for now is a remote desktop web access role service target right here. Let me hit OK, and again, be OK with changing the target type. We have some conditions that exist here as well. I'm not going to worry about those. And in this case, we don't even really have to worry about a specific group, although we could create one because all the data is going to exist here in this remote desktop web access role service class that we've configured here. So I could configure this or adjust the group if I wanted to just bound it down to those machines. But because we'll actually only have the machines that are actually contain data or that have data in this class, we can make things very simple on ourselves and just include this for all the data that exists. If I hit OK here and save the view and again allow all those background processes to occur, after several seconds, we should now see, there it is, our web access server health view right here. So this does now correspond with that web access, remote desktop web access class. Here is our healthy state right here. And hey, what do you know? There is the view for any of those objects that contain or are actually in that class. So I can now start and stop the IIS service. If I click any of these, this will actually now go about actually stopping and also starting that service on that machine. Here is rdsweb.company.pri, and if I run this, it should end up with a successful response right here in just a second. Indeed, we now have a successful response there for this configuration. And so I could now actually go through and restart the service if I wanted to here as well. So this should give you a feel for how you can now go about creating your own individual tasks that are framed in with the views that you've created and made available to different users. If you get a feel from those users in terms of what kinds of tasks they might want to perform, and if it's something that can be constrained into either a script or a single command line, whether that be the traditional command line or Windows PowerShell, you can make it available here right there in the view. So now we have a couple of views that we can work with. And admittedly, yes, we are working here with just state views here so far. But I can show you here very quickly that if you go to create a new view, the process to create the different kinds of views is more or less the same. The different ways in which you bound the information will be slightly different depending on the view that you create. The criteria tab over here is more or less the same as what we saw. Obviously some different conditions, but it's over here on the display tab where things will get slightly different for the different kinds of views you're creating. If I'm creating, for example, a performance view, I'm going to have different ways in which I can then display this information if it were an alert view versus a state view. But there are some situations, though, where rather than just having this single representation of information, which is how I'm limited anytime I'm creating a view, I may rather prefer to have a way to represent multiple different types of information in a single pane. The way in which I do that is by using a dashboard. These dashboards are essentially collections of views, which we actually term widgets inside a dashboard, but they're effectively the collection of different types of views into a single pane of glass. Let me right-click here and again drop this in my DEN RDS Servers Management Pack, and this time I'll create a dashboard view. Microsoft provides several layouts that exist here by default. There is a column layout and a grid layout that are kind of the basis for most of the dashboards that you create. There are also some pre-generated ones, like an object state and summary dashboard that you can work with. Even our SQL Server Management Pack has added in its own dashboard template that you can use. And presumably other MPs that you install may have other templates that then get added here to this list. But for the most part, many of the dashboards that you create, especially if you're customizing your own dashboards, will generally start from a grid or a column layout. I'll choose here the grid layout because it's kind of a superset of what you get with the column layout. Obviously, a column layout only provides access to columns. This grid layout allows me to, number one, provide a name. So let's call this DEN RDS Servers Dashboard, or maybe our Health Dashboard. And our grid layout here allows me to identify different layouts depending on the number of cells, which they themselves are the different kinds of views that I want to add here into the dashboard. So if I have 3 cells, I have a different selection of options there versus what I would have for 5. Well, let's say I want to create a dashboard that contains alert information right alongside the state information, and just the computer state information is what I'm looking for. Let us create now a column-oriented grid dashboard here of these 2 cells, which in doing so, I'll first need to go about actually creating the dashboard itself. Once this dashboard is created, then the next step in the process is to go through adding in the widgets, which they themselves are representative of views. You'll find there are more different widget options than there are view options available, but these widgets then populate the dashboard with the information of interest to the person actually looking at that dashboard. Let's start here with the state-based dashboard. So let us now use a widget, and specifically our state widget here, to define what information should exist there in that leftmost column. You'll notice here that we actually have a larger number of widgets than the number of available view types that exist. So in many circumstances, you may find that a dashboard will actually provide better access to information than individual views. I'll leave it to you to take a look at all the different widgets. It's actually kind of fun to play around with which widgets better represent the information. For now, though, we'll choose a state widget and an alert widget, with the state widget being first. For this, let's do our RDS servers, and we just want to focus, for this particular one, on the computer object state, so the raw computer object state that relates to the generic OS metrics that we're capturing. So let's do computer state here. Here's our RDS server's computer state. I'll choose next, and then scope this down to our RDS machines. Right down here, let me punch in DEN to scope it down to our DEN RDS servers right here. If you recall, though, that that group that we configured actually had 6 different objects in it. 3 of the objects were computer objects, and 3 of the objects were health service watcher agent objects. If I were to scope the members here to just object, this would include all 6 of those representations. But the widget we're defining here is only for that computer-oriented information, so your raw OS metrics. So we do really want to scope these down here to just include those metrics. Let me punch in here computer, so that I can use computer, and specifically this computer item right here, that the class of information, as just those objects that I want to include here on the dashboard. Let me choose next here, and I can define any criteria I should want, and then also which columns I want to display. So my icon, path, health, maintenance mode, and display name. As before, I can sort them and group them if I wanted to, but I'm not going to do that just because I'd only have 5 columns here that I'm working with. If I choose next and create, this will go about now creating the visualization, again, focused on that information contained within that computer class. Once this process completes, I can choose close down here, and what do you know? There is the dashboard that I've created. For RDCB, I can see my health, I can see my icon, and if there was a path there, I could see it as well, and if it was in maintenance mode, I could see that as well. As before, I can also just choose to view Health Explorer here to find, again, that raw OS related information about any of these machines. This should give you an example of why we've created the group in the way that we have to include both those computer objects as well as a different class of information that can be useful in other ways. And so as you're going about creating your groups, you might want to think about actually what kinds of objects you do want to include in that group, so that you are bounding the information that it generates to whatever use is defined here by the management packet. Because again, the MP is going to contain the group and the views and the dashboards and everything all in one tight bundle. Let's continue this process over here and add in a second widget, which in our case here will be an alert widget. For this, we'll do DEN RDS servers alerts. And again, I'll put computer alerts here. So just to focus on those raw computer alerts. As before, we'll once again type in DEN here to add in our DEN RDS servers right there. And we can choose then what kind of criteria we want for defining the severity, the priority, and the resolution state for the information we're interested in. It is here where you want to be particularly careful with these specified resolution states. Right over here, if we were to include all the alerts that were both closed and resolved, this would actually probably give us a bad representation of the machines we're looking at. I'm not particularly interested in those errors that actually have been resolved and later closed. I'm only interested in those that are still relevant to the machine. So actually bounding this down to just these 5 is a great starting point for the types of alerts I'm looking for. I don't really want to see those that have been resolved and closed, because that's in the past. I don't want to worry about it. If I choose next here, I can choose which columns I want to display, like things, the severity, the source, the maintenance mode, and so on. Out of these, there is one column that you probably want to include in any alert-based view that you're creating, and it's right down here, is monitor alert. This is monitor alert column right over here is one that I tend to drop right up here as the first column in any list of columns. The reason for that is that, and we'll talk more about this and the specific differences when we get into monitors and rules later on here in this course, but there is a very big difference between a monitor and a rule. A monitor is designed to be a state-based representation of a certain aspect of a system. And so because of that, if the system is then resolved, the monitor will switch all by itself from red to green. If the problem then reoccurs, it will switch all by itself from green to red because the state of the system itself has shifted from one that is in compliance to one that is no longer in compliance. This is different from a rule where it's not state-based, but whether or not you fulfill the rule at the time the rule actually kicks off. And so for that reason, you never want to go about actually resolving or closing any alerts that are generated by a monitor. You only want to do those that are generated by a rule. This all just has to do with how monitors and rules are configured there in the system. And so for that reason, when you are configuring any of these alert-based views, you do want to include this is monitor alert checkbox here so that your users do not attempt to resolve or close any alerts that have to do with a monitor. They will resolve themselves on their own. If I choose next over here and create, that will now go about now creating the visualization, which is the right-hand side of the dashboard that we've configured here. After a second or so, I can choose the close button once again, and we should see here if there are indeed any alerts right there. Here's an alert that we have here on RDCB, and indeed it is a monitor alert, so it's not one that we want to resolve or close. So here you have an example of a dashboard, and from this you can now go about creating whatever manner of dashboards and then widgets within those dashboards that make sense for the consumption by your other IT administrators. One final topic then is locking down access to the dashboards and the views here for those specific set of users that are responsible for managing our RDS servers. This returns us back over to our administration tab over here, where as before we're taking a look once again at the available user roles. Recall back in that last course where we went through the configuration of user roles and how we talked about these different user roles have different types of accessees. A read-only operator, obviously, will only have the abilities to read the information there in the dashboard. An operator will have the abilities to read the information and then interact with it, performing tasks like resolving alerts and so on. And so being able to have that further access and also doing tasks and all the other things that we want to make available to those RDS administrators probably drives us toward an operator role that we'll want to configure for those users. So let's go ahead and create a new operator user role here for our DEN RDS administrators so that they have access to just the views and the dashboards that we've configured here so far. Let me add in my global group here, which I've configured in my Active Directory domain. This is the RDS admins. There is a single user there in that RDS admins group, so we should be able to see what their view looks like once we complete this wizard here. And it's here under the approved groups page where you have to pay careful attention to the types of different classes of information that you have made available to those users there in the views that you've configured. You may feel that you can come down here and just give access to the DEN RDS servers group, but this will only provide access to whatever objects have been collected there in that group, which in our case are two different kinds of objects, computer objects and health service watcher agent objects. As you go about creating more views, you may contain additional information here that requires you to add in other checkboxes here. So you just be careful here in terms of what you make available. It's worth mentioning also that if you wanted to make available access to all the information and then later to scope it by tasks, dashboards, and views is an altogether different approach. So limiting access to the ways in which you access the information, but not scoping access to the information itself. Here in this case, I can provide access to all the tasks that are automatically approved, or I can choose to grant explicit access to only those tasks that have been approved. If I were to select all the options there in the group scope view, I would probably want to come down here and identify which tasks have been approved. Again, these will change depending on what object type that user is working with. So sometimes you can actually create yourself a problem by trying to lock down access to the views and the task information by selecting all the options that exist here. I will allow all the tasks to be automatically approved because I have selected things down or scoped them down using the Group Scope tab there above. I will choose next down here and define now which dashboards and views these users will be able to work with. Down here, I want to make sure that right down here at the bottom, only the views in my DEN RDS servers will be those that this group has provided access to. It is worth mentioning here too that if you add additional views to that folder, you will need to come back to this wizard and then provide specific access. So there isn't the concept here of permissions inheritance like what you typically see there in NTFS files and folders. If I choose OK here, these are the dashboards and views I'll provide access to, and I can further approve which task pane dashboards I also want to provide access towards. If I choose Next here and Create, this will now create the new role for my DEN RDS administrators. I can verify if I've done everything correctly by logging out and then logging back in as this user, or I could actually then log in as this user to show you there using the web portal exactly what this user will see. So let's actually come over here and then come over to our web portal here for Operations Manager. And I have the Donna Jones account here, so D Jones, and then the password. So I can log in here to get a look at what exactly this individual user will see when they then log in using their credentials. Down here you can see I provided access to this account using audit collection services before. They were also a part of that auditors group back in that earlier course. But you can see here now for my DEN RDS servers, I can see 3 views here, really 2 views in a dashboard that exist. And indeed, here is all the content that exists here for my web access server health, and also down here for my DEN RDS servers up-down state. I will let you know though that because I'm using Edge, that the dashboard views are not supported here on this browser. I think there's a Silverlight requirement that we have to have in order to view these dashboards. But this gives you essentially a representation of what you can now make available, either again in the Operations console or over here in the web console. So whereas the generation and creation of these dashboards and views may be a bit of an art project, it is really scoping down to what kinds of content you want in those views and dashboards that is really the most difficult part. What have we talked about here in this module? We've gone through the different views and dashboards and how to configure some special use cases. We took a look at what the default views are. We also there took a look at the different kinds of data that feeds information into those default views. We looked at that special use case there with our network monitoring dashboards just to give you a feel for what exists already there on your environment even before you go about creating your own. From there, we created that up-down monitoring view for all the computers, took a look at how we can declutter the monitoring pane by deleting the folders that relate to management packs that we don't really intend to include views in. And then from there, went through scoping the view using groups to create just that view for the different servers and services that make sense for their administrators. From there, we added some tasks there into the views that we created and even took those views and assimilated them together into a dashboard as individual widgets. And then lastly, concluded there with the permissions that we need in order to grant the right users access to the right information. Coming up next, we have what is actually a very much smaller module, and one where I probably honestly could have included the content here in this module. In that next module, we'll be talking about service level tracking, the generation of service level agreements and service level objectives to create a kind of master top-down view of the entire health of environment. If you have requirements levied upon you for a particular amount of uptime, 99.9% or what have you, having this separate system, like an operations manager solution, that can provide hardcore metrics for determining what your service levels are, can be really handy for proving that you are indeed doing a good job with your servers and services. In the next module, we'll talk about service level tracking and how all this gets generated really there as a set of dashboards and widgets, very much similar to what we've seen here in this module. That conversation on service level tracking, its implementation and visualization is the topic for our next module coming up. You can argue that the content here in this module on configuring service level tracking might just assume be included there in the module we just concluded. Really, when we're talking about service level tracking, the most of what we're doing here is visualization. Indeed, we are going to be configuring some service level objectives and also in there within some service level agreements. But the main thrust of what we're doing here is actually setting up the dials and widgets that allow us to then graphically represent how well we've met our requirements. But rather than include it there, really to almost bury it there within all the other content in that very large module, I thought it important here for this particular kind of visualization to separate it out. Here in this module, we only have a couple different tasks to discuss. that in some ways are preparing you for how to create these dashboards, but in other ways are also then teasing how we may later use this functionality in the course coming up. They're on web applications and Azure-based applications. I say that because the ways in which we configure these service level objectives are great for example, the group that we've built here already for our RDS servers. It's great for defining what the uptime is for that group with using a numerical expression. But later on, as we start getting into distributed applications, which I know we haven't done so here yet, and particularly when those applications are web-based, or at least configured in such a way that we can get a feel numerically for their response time, these distributed applications are really where the real power will then later come as we start building web applications and monitoring their use. And so I'm going to show you here how to configure SLOs and also a dashboard for a distributed application, even though I know we haven't created one just yet. But we'll use one of the already available distributed applications that have been created for us when we downloaded and imported in those Active Directory management packs. This should at least sort of kick off in the back of your mind how we will later be configuring those distributed applications when we start creating our own custom applications later on. As part of this, obviously, we do have to configure the SLOs in an SLA and then also then insert it there into a dashboard. That's one way in which we can visualize this information. The other way is in running a service level tracking report. And I include this here separately only because I just want to show you where those tracking reports can be found. Just like any of the other reports, this presents you a way to deliver that report to some other person, likely here in the case of an SLA, perhaps a manager level person, for giving them that single numerical value that describes then your application's measurement of health. Now, we've all seen or worked with SLAs in the past, and many of us actually have SLA requirements that are levied upon us. But the actual numerical requirement, so 99.9% of uptime, is sometimes very difficult to quantitatively measure. It is actually providing those numbers and giving some real math behind those numbers that is a reason why we want to create these service level objectives and then drop them there into a dashboard for other people to see. Let's start first by actually creating the service level objectives for the group that we've configured here so far. This is our DEN RDS servers group. So right down here, you can see the management pack, the folder, and then also the dashboards that we've configured here so far. We will eventually be configuring a dashboard here to represent that picture of health. And so let's start here with a very basic one, where we'll start over here in the authoring pane and take a look at this service level tracking node right down here. Let us begin by creating a new service level agreement here, which we'll call our DEN RDS servers SLA. This will represent the availability-oriented SLA, just essentially what the uptime is for the servers in this group, as an initial way in which we can kind of just get a feel for whether or not we're actually meeting our requirements. I'll choose next down here and choose the class of object here to target, which in our case will be not a distributed application, but a group. This group will be our DEN RDS servers, like the one that we've configured with and have been working with for the last couple of modules here. This group contains, as we configured back in that last module, 6 different objects, so 3 computer objects and 3 objects for that Health Service Watcher agent. I'm going to make use of those Health Service Watcher agent objects here because their red versus green state lets me know whether or not the machine has been up or down over a period of time. And so I'm just going to kind of steal from the work that we already did back in that last module to then represent it here using this sort of dial-oriented interface that we see here with service level objectives. Let me then click Add here to add in what is termed a monitor state SLO. This monitor state SLO is different from a collection rule SLO in that the monitor state, just like typical monitors, represents whether or not it is healthy or not. A collection rule right here actually takes a look at a performance collection rule, which we can configure down here to identify if, for example, processor use is over a specific percentage. More often than not, these performance collection rules, at least as we move into more web-based applications and those that are perhaps up in Microsoft Azure, these might not necessarily be processor-oriented or memory-oriented, but rather latency-oriented. So how long does it take for an instruction then to be returned if I send a query off to some web application somewhere? We will spend more time on these performance collection rules later on in the course coming up as we start working with those web applications. But for now, I'd like to focus our attentions here on this monitor state SLO because at face value, this is actually the easier rule to work with. Let us call this just simply uptime as our service level objective name. And the targeted class here is actually not going to be the DEN RDS servers we're looking for. We need to dig into that class to get the actual monitors that we're interested in then collecting to generate this percentage value. As before, this will be our health service watcher agent class right here. This health service watcher agent, if you recall back from that last module, turns red whenever the system is down. So this is essentially turning up versus down into this numerical value that represents our service level objective goal. Now you're used to these goals, 99.999% availability or 99% availability or whatever you have agreed upon with the rest of your organization. Let me set this here as 99%. So that is our SLO goal here for these particular servers. And I can define here which of the states I don't want to count, as in subtracting from that goal. So unplanned maintenance, unmonitored, monitoring unavailable, and so on. I'll just leave these the same here, although you will want to adjust these depending on what you choose as you're going about rolling these actually into production. When I hit OK here, that creates the SLO, and if I hit Next then and Finish, that completes the SLA, which I can now then add in to a dashboard I need to create over in the monitoring pane. So let's come over here now, here under Close, back over to the monitoring pane, and take a look at how we now create this dashboard. Here under our DEN RDS servers, let's once again create a new dashboard view here. And what we're looking for is the service level dashboard right here. This service level dashboard, we'll give it a name. So this will be our DEN RDS servers SLA. And if I choose Next down here, I now need to scope which SLAs will be presented here inside this dashboard. For this, I will choose the one that I just created, so my DEN RDS servers SLA. This is the service level tracking object I just created a second ago. If I hit OK here, that adds it now to the list of those that will be displayed here on this dashboard. And let me back it off here. Instead of doing 24 hours, let's do, for example, 7 days. You do want to make sure that whatever value you put in here, that you actually do have data to support that value. If you don't, you'll end up with a bunch of blank spaces there at the dashboard you'll create. For us, though, we can put 7 days because I know we have at least 7 days of content here. And if I choose Next and Create, that will now create the visualization. This will, here in a second, now take the up-down metrics that we've seen over time and translate it into that percentage value of how up we have been over the past 7 days. Let's allow it to complete its background processes here. And after a second or so, and a couple of screen refreshes there, it took an extra second or two to actually render the data. We can see now that we have some data here in the dashboard. Notice here that the dashboard actually has some scroll opportunity down here on the bottom because we are seeing the red X here that shows that the service level has not been met. But because of how we've configured this for 3 individual objects, these 3 instances here of the Health Service Watcher agent, we can see now that in the past, our RDS web machine has 100% uptime, our RDCB machine maybe not so much, and then if I scroll down once again, our RDSH machine also has 100%. So we're actually violating our SLA here because of how that RDCB machine was really powered off until just very recently as we were filming that last module and I powered back on RDCB. So this does give you a good feel for what you can configure here with these service levels, but this here really is the availability of these individual machines. Later on, we'll talk more about how you can use performance metrics to get a better feel for the actual reaction of individual services like web services. But this is a start here in helping you understand how, for a group of machines, you can really get a good feel for exactly what your uptime is over time. Now, I know we haven't talked much about distributed applications here just yet, other than my teasing that ultimately will be the later goal you're looking to get towards. We will talk about those later on here in this course, but I want to spend some time while we're here on these dashboards talking about how the distributed applications we will later be creating can also be added here into the dashboard, the SLA dashboard we've configured here so far. I will show you that when we added in those Active Directory management packs earlier, that the addition of those MPs actually created a distributed application here for us. This is our Active Directory topology root application right here. And without going into further detail on what a distributed application is, recognize that this is just one way in which we can consolidate together all the different pieces that make up an Active Directory into a single tree for helping us understand what the overall health then is of that tree. It is easiest to visualize this by taking a look then at the diagram associated with this distributed application, where you can see Active Directory, and then below that being the domain here, company.pri, and then below that being the other elements that make up the custom, at least custom from Microsoft's perspective in this case, the custom configuration for how all these different dependencies then align together. So in this case, our site, for example, is dependent on objects below the site, which is right here, this computer object, which itself is then dependent on further objects down the tree. These, as I said, are ones that are configured here by Microsoft, and so I don't want to spend too much time on the actual diagram, but just recognize that this is one way in which we will later be representing, in our case here, our RDS solution in a tree-based view for getting a feel for the overall health of this as a service and not just the individual components. We can, though, take what we have here in this diagram view and the distributed application all by itself, and then create our own service level agreement and service level objectives to represent what our goal is for the overall availability or performance of Active Directory. And so let's come back here to service level tracking and create a new service level agreement here. Let's call this Active Directory Topology Root. So just mirroring there what the distributed application is called. And without caring again what the contents of it is, let's now create or select this as the class of object we're looking for. So there's our Active Directory Topology Root, this being a distributed application. And then we'll throw that here into, even though it doesn't really belong there, we'll throw it into our DEN RDS servers MP. For our service level objectives, we again have the abilities to add in either a monitor state or a collection rule SLO. We'll talk more about those collection rule SLOs in the course coming up. But as before, we can now choose for this topology root a new uptime service level objective that we're looking for. So let's call our service level objective name here uptime again, with the targeted class in this case being the Active Directory Topology Root. This will then represent the sum total of all the issues that may be going on beneath that level there in the diagram that we just explored a second ago. And so this kind of gives us the top level, top line understanding of what the health is for our Active Directory topology. I will again set the monitor here to availability, and I won't change the service level objective goal here. Once I've done that, I can choose next and then finish to create the service level tracking object, essentially the SLA that we'll later then add into our dashboard. And then once this has been created, the very last thing is to visualize it back over here under monitoring, where we just simply add it back into the configuration that we have here. Let me make that configuration change here by adding in this new representation here for our Active Directory topology root. So just adding this in as another metric that we're interested in monitoring. Once I've done that, let's update the view here, and after another second or so, and also some additional refreshes here of the screen, we should then be able to see some additional data that relates to the health of our Active Directory. As before, these metrics do take just a little bit to generate here, but after a minute or two, we can now see the service levels then associated here with Active Directory itself. So this is not really our RDS servers, but rather the service level for our Active Directory topology root. And right down here, you can see a 100% uptime. We haven't actually powered down the domain controller here. And so the availability metric here for Active Directory is 100%. For everything we've done here, we've focused our attentions on availability, so whether or not the service is up or not. But if you kind of think in the back of your mind with the other metrics that exist, like performance and security, you can see how actually gauging the response time of a service can also be handy for helping you understand then from a top-level metrics perspective how well you're servicing the needs of your users. This can, just like all the other metrics we have here, be handy for helping you recognize whether or not you're meeting your requirements. One final topic here that should be relatively self-explanatory because we've already done this before is the generation of reports on the information we're seeing here. Let me just show you that really where the report is. If I come down here under reporting and we take a look here at the Microsoft Service Level Report Library, it's right here where I can generate a service level tracking summary report. Again, just like all these reports, these are useful for people who wouldn't necessarily want to or have access to the operations console. And so if we open the report here, I'll just show you that the process of running the report is relatively easy here. I will run it from yesterday to today. I will run it against the service level for, if I search on it, right here, our DEN RDS servers SLA right there. And once I do so, I can choose all the different additional time details I would want to report over here on the right. And so running this just essentially presents what I see there in the operations console, but can be set up to regularly then deliver this report either to a file share or to email somebody if they have need to understand what this top level metric really is. You can see here after a second or so that we actually have the report being generated, and then the information right down here that shows that we're at about 91.64% uptime, which is just below what our requirement is of 99%. So our very short topic here is indeed one that probably could have been included back in that last module there on views and dashboards. But I think our discussion here on service levels and how this will dovetail into what we talk about in the course coming up can be particularly useful. I didn't want to necessarily bury it over there in that module before. What have we talked about in this module? We've gone through the configuration of service level agreements and then the service level objectives that then feed into those agreements. We've done so here for a group of machines, our RDS servers. And we also then sort of tease this notion of being able to do so for a distributed application. We took a look at one that was an example, and we'll later take a look at it again as we go about creating our own custom distributed applications later on. And then from there, we took a look at then running that tracking report there so that other users outside Operations Manager can take a look at the results of this top level metric that describes the entire health of our environment. Coming up next, we kind of sort of shift gears here into then making available the alerts and other notifications to people who aren't looking at the operations console. In the next module, we'll go through the configuration of alerts, subscriptions, and knowledge, which are ways to obviously alert people when certain conditions occur. We'll talk about the configuration of which alerts you do want to push to people's pagers and in their inboxes, how you set those up with subscriptions, and also how you might add in your own specific company knowledge to provide better information for the alerts that you see. That conversation on alerts, subscriptions, and knowledge is the topic for our next module coming up. The operations console might be a pretty great place to find out information about the behaviors of your servers and services, but not all of us will always want to spend all of our time there in the operations console. It's for this reason that we have the need to let ourselves know through alternate channels when there are alerts and other conditions that require our attention. Actually, configuring those elements is exactly our topic here in this module on configuring alerts, subscriptions, and knowledge, where we take everything we've done here so far in setting up all the views, all the visualizations there in our operations console, and then extend it out to other ways in which we can let ourselves know that something's gone wrong. Here in this module, we'll go through the configuration of first what are termed channels, or essentially those other mechanisms for letting us know that those activities have occurred. These are things like email or instant messaging, SMS messaging, for example, or even setting up some script that performs some out-of-band activity that lets you know an alert has occurred. The subscribers then are who actually needs to be alerted when a problem occurs, and then the subscriptions are what do you want to be alerted about. In doing so, we then need to actually dig a bit deeper into the individual alerts and also just the states and monitors and every bit that we've talked about here so far in exploring those different alert-oriented configurations across the rules and the monitors that we see here so far. When we have rules and monitors that are included as part of a sealed management pack, so one we've downloaded from Microsoft or a third party, well, the reconfiguration, actually the exposure there of the alert is something that occurs via an override, that same override process that we did earlier for tuning those rules and monitors. Later on, as we get into the creation of our own rules and monitors, there's a bit more flexibility in terms of how you actually create these alerts. But for now, I'll show you the override process here so you can then make some adjustments to what you already have in the management packs you've downloaded. I want to spend a very quick minute here on populating company knowledge, which really is just opening up more or less Microsoft Word to punch in whatever specific knowledge you might want to add to a rule or monitor that just provides more clarity, more color commentary, if you will, on what exactly a person should do when that alert pops up into the interface. I want to talk also about maintenance mode and the configuration there of maintenance schedules, which are your way to ensure that Operations Manager does not then alert in those circumstances when you are performing a planned outage. Back over here on my desktop, we're once again taking a look at this Windows 10 machine where I also have a copy here of the operations console. And I've still got a couple of these alerts that are up here in the active alerts view, which I have honestly left around just so that we can use them as examples for what we might want to enable or where we might want to enable these different notifications. One of the first things we need to do, though, is actually figure out how we're going to notify the people when the alerts occur. That process happens back over here under administration, where right down here you can see the notifications item right here in the left pane. We have three different things we need to configure. First are the channels, essentially how we'll notify a person, the subscribers, or who, and then the subscriptions, which are effectively the what. Let's begin this process here with the channels, where we can take a look at what are the four different options that exist here for actually letting people know when an alert has occurred. We have here an instant message process here, which uses the SIP protocol. If you have an instant messenger server in your environment, you can use. We also have the abilities here to use SMS. So if you've got standard text messaging, you can do so as well. Or even running a command. If you have some extra third-party solution out there that has some command-based interface, you can set up a script or some command to then invoke this command whenever the alert occurs. Whatever you enter in here will need to include the command line parameters, as like what you can see here, that also include the information about the alert name, description, and all the stuff that will be necessary for the execution of this command related to the alert. So you'll see here a long list of the different variables that you can include as you go through entering in those command line parameters. These will then populate with whatever information exists there in the alert, so that when you do run that command, well, it'll have all the necessary information for what it attempts to accomplish. Out of all of these, the one that we can actually sort of partially configure here, although indeed we don't actually have an SMTP server here in this environment, but this is the one that is probably most likely for you to use in setting up a connection between your email server and your operations manager infrastructure here. Let's say, for example, that you do have a server that is running SMTP, and that might be, I don't know, mail.company.pri. For that, we've got our standard SMTP port number 25 here, and we can also choose which authentication method we want to use. If you do anonymous, obviously you will need to configure that server to allow anonymous connections from this server, so from MGMT in this case, or you could use one of the other authentication methods that exist here in the drop-down list. Again, we don't have that here in this environment, so I'm not particularly worried about configuring these with any kind of configuration that actually will work here in the environment. We're mostly just setting up a dummy account here to simulate what you would do in production. I will put a return address here of scom@company.pri, and I can even set up a retry interval if the server on the other side, that SMTP server, is down. Where the real meat and potatoes of actually how you're configuring this occurs is in the third of these different wizard pages, where you actually go about defining what the email subject and also the message will be here. This, as you can see, also includes in those different variables like what we saw just a second ago. So you can see here that we actually are configuring, using this different notation, a way in which we can include things like the alert and the source and the path and when it was last modified and so on. So this should give you some flexibility then in determining how you actually want these alerts to appear in people's inboxes whenever they occur. You can also set down here the importance and the encoding as well, depending on what kind of encoding you require. I will say that you may want to consider the importance here as being something maybe perhaps not high importance, only because, at least at first, a lot of these alerts sometimes can really fill people's inboxes with what will then be highly important messages there for them to review. Later on, as you get into the further tuning of this, if you feel it necessary, you may want to set up different channels for which are considered normal importance and which are considered high importance alerts as they occur. And so I'll choose this as normal and choose finish here to go about now configuring this email notification channel. Again, in this environment, this isn't actually going to work, but this is the first step in the process for actually getting these notifications set up. Next up is the configuration of who, or essentially the subscribers for the different channels that we've configured here so far. This configuration here actually exposes quite a bit of flexibility in terms of how you want each individual user to be notified. So for example, if during the day you want your users to be notified via instant message, and at night you want them to be notified over email to some specific email address, you could do so through the configuration here. We start this process by configuring a new subscriber here, which we'll actually focus this then on our use case, the ongoing use case of our RDS servers. If you recall, we configured in Active Directory an Active Directory group here called RDS admins that includes that single user, that D Jones user, that ostensibly is the RDS administrator for the different machines under monitoring. And so here, let's configure these RDS admins as a subscriber for the different kinds of RDS-related notifications that they may want to receive. I'll choose Next over here, and it's right here where we get kind of a sometimes confusing wizard page. This is the master schedule for the delivery of any notifications across this subscriber. And so I could limit this to specified times if I wanted to, and during those periods of time, no user would be notified using this subscriber, and then through the configured channels we'll take care of later. Alternatively, I can set this also to always send notifications, and then later on tune down where and how those notifications ultimately make their way to the users that are here in this list. You can see here, if I choose Always Send Notifications, it's here under the list of subscriber addresses, where I can identify which of the channels I want to use during which of the days of the week or hours of the day, so that I can split apart how my users get notified. I could, for example, here set up two different subscriber addresses. So one that would be an instant message oriented one, and another an email based one that would do different things depending on the time of the day or the day of the week. Let's say, for example, that during the day, during the usual daytime hours from 9 to 5, I could set up this address name here as instant message, and if I had actually configured the channel over there, I would then have this information here as the delivery address. Again, this is all just simulation here because we don't have those in this environment. But let's say here for that instant message channel, I want to send notifications here only during the daytime hours. So from, for example, 9 a.m. to 5 p.m. This would then send those notifications during that period and during that period only. Once I've done this, I can then set up a secondary schedule right up here that would be an email-oriented schedule. In this case, I've just put email here and identify the channel as that SMTP channel right here. When I do so, I've already configured the channel, but I do need to set up the delivery address. So which group of users there that I've already configured on that email server should receive any of the notifications that are directed here to this list of subscribers. Let's say that over on my email server, I've already configured a group called RDS admins at company.pri. This then becomes the delivery address for that selected channel. And then down here, I can then choose to only send notifications during specified times, which would be from, for example, in our case, 5 p.m. here. And then that would be until, let's call it 11:59 p.m. And then I need to repeat that then for the next morning. So that's the first schedule. And then the second schedule would be from 12 a.m. then over to 9 a.m. in the morning. This would set up that schedule. So from that period of 5 p.m. then to 9 a.m., we would send those alerts out to users through their regular email address and not through instant messaging. If I hit finish here and finish once again, this now configures these subscribers to have these two different modalities for how they end up receiving these notifications. Lastly then is the what, effectively which of these alerts you then want to send to these different groups of users and over which channels. The subscriptions then really should be the last of the configurations you make because it does require you to have the channels and subscribers then set up. Let us choose New here, where we can see, if I minimize the taskbar here, where we can see things like the subscription name and then also the criteria and subscribers to where we want and who we want to send these notifications to. Let's call this RDS admins notifications, and I'll choose next down here. Right here are going to be the conditions that relate to any of the specific groups or classes or instances to which you want to then send out these notifications. In our case here, we do have that specific group we're interested in, which would be those RDS machines. If I filter here by those DEN RDS servers, I could add those in as a selected groups here. Be aware, though, that when you are configuring these alerts, that as before, as we were using groups to bound the information that exists there in a view, there may be some circumstances where these groups do not necessarily bound the right information for the notification you want to send out. So be careful here with the use of groups, but this is, if you have configured things correctly in the group itself, recall we have two different kinds of objects there in that group, this can contain the information if you are very careful with how you set up the group. So for this would be our DEN RDS servers group, but there are a lot of other conditions we can configure here. If I choose next, I can then identify the subscribers and the channels for who should receive this information and how. We have here a subscriber that we've already set up, which is our RDS admin subscriber here. I don't need to create a new one because I've already gone through all the extra work, where you can see now that the split between the instant messaging and the SMTP channel types are already set up here in the list of subscribers. Once I've done that down here, I can set the channels for notifications that are generated by this subscription. And again, if I choose add over here, I can search for that SMTP channel that I configured before. So again, plenty of flexibility here for how you end up setting up these different channels and subscribers when notifications need to occur. This bottom one down here is one that can be useful when you do have notifications that perhaps are monitor based. If you have this situation where a monitor has changed from green to red, and it stays in that red condition for a period of time, you then know that really this is probably a situation that you want to take a look at. Sometimes, however, these monitors will shift from green to red and then back again very quickly. There may only be a single blip in the behavior that Operations Manager is monitoring that very quickly resolves itself just due to some internal weirdness that is there inside the engine. And so you can see here that delaying sending notifications after a period of minutes can help tune down the broadcast storm that can occur if you've got some monitors particularly, that are flipping back and forth between green and red. I will set these to send notifications here without delay, choose next and finish to then create and enable the subscription notification. Now, obviously, I've kind of stepped through this relatively quickly because out of the three here, the channels and the subscribers are, for the most part, self-explanatory for how you set them up. It is really here in the configuration of subscriptions, and indeed the types of alerts that your users are interested in receiving, where you really will find yourself doing most of the work. Here we've done a very basic configuration where anything having to do with that group of RDS servers is going to get a notification to those users. But not necessarily every alert related to that group may be necessary to wake people up in the middle of the night. It's for this reason that, as I said, the majority of your work here will maybe not be so much in configuring your channels, but rather in tuning which alerts then get pushed to people's inboxes and pagers and other notification mechanisms, so they aren't woken up through some alert storm for an unimportant rule or monitor change. Let's start this process by first taking a look at the differences between how a rule and a monitor look here in the interface. And this will actually help us for the next module as we get into configuring our own monitors and rules so that we know what we should be prepared for when it comes time to actually custom create those that we require. Let's first take a look here at just a couple of examples here in the alerts that I have maintained here in the interface. Here I have an alert here on Network Adapters DNS Servers Health, where right down here you can see that this is an alert monitor. This is different from right over here where we have an alert rule. We'll talk more again in that next module about the main differences between monitors and rules, but as I've said already, a monitor is a state-based representation of some element of health, and it tends to resolve itself whenever that state then changes to something it likes. A rule, however, is whenever you do not actually fulfill the threshold for that rule, and it does then require manual resolving and closing of that item for it to then eliminate itself here from the list. What I mostly want to show you here is that if we take a look not so much at the properties here, so the monitoring properties, but rather if we take a look at the actual rule itself, the information that we'll see here is just a bit different for a rule versus a monitor. And again, this is for our purposes here and also for our purposes in that module coming up. This rule, for example, is a rule category of alert against our management server. And the configuration right here takes a look at this data source and then runs some sort of expression against the data source. In this case, if we end up seeing an event, specifically event ID 11852, we now know that we've tripped the rule and we need to make an alert here in the interface. This lets us know that if we see that in the event log, we know that there's a problem, and now we need to resolve that problem because it has here tripped this rule. Once the rule then trips, right down here are a list of possible responses that we can configure. So in this case, this will be the generation of an alert, which right over here, if we view it, the generation of the alert includes this information here in the alert description. You'll notice here that because this has to do with a sealed management pack, that we can't actually make any changes to anything here. It's only later on as we get into the custom creation where all of these items then become modifiable because we're not in a sealed management pack situation. But this should give you some information then about what exactly is going on then when these alerts end up here in your active alerts view. Things are a little bit different if we move from a rule down here to a monitor, where again, I'll take a look then at the settings here of the monitor, and we see quite a bit more information here because, again, that state-based orientation of the monitor requires it. Without focusing on any of the other items here, let's go right over here to alerting, where we can see whether or not this monitor generates an alert when it goes from green to red. Right here we can see that in the sealed management pack, we are generating an alert when it is in the critical or warning health state, and that the network adapter's DNS server's health monitor has failed. Right there is the alert description that ends up here in the interface. So this gives us a feel for what exactly or why we're seeing the rule here, because we have then tripped this monitor from green to one of the other states. As you might imagine, the actual configuration here of these monitors requires us to then not so much change the alert or change the configuration. Remember, we are dealing with sealed management packs where we can't make changes, but rather to use an override as the mechanism to actually enact the change here from what we have here by default. Let's take a look now at how we might use an override to generate an alert for some situation where the monitor by default is not configured to actually send an alert here to the screen. Let's come back over here to our computer's up-down state view right down here, where we can see all 5 of these machines are currently powered on. For all 5 of these machines, we're monitoring the state of the Health Service Watcher agent, so this class, this target here. And right now, there really aren't any alerts that are being generated if this Health Service Watcher agent shifts from green to some other configuration. I know this because if I take a look at the properties of the monitor itself, I can get more information about whether or not it has been configured to generate an alert. Now, I can't really come over here and view properties or view open. This doesn't give me the information that I require. Rather, what I want to do is come back over here to authoring and to take a look here at the Health Service Watcher agent itself. Let's come here under authoring and take a look at this monitor because I happen to know it is a monitor. And let's rescope ourselves here to get rid of that remote desktop stuff. And down here under view all targets, let us first clear everything and then look for our Health Service Watcher agent right here. This is the target and the class of information that I want to take a look at. We have already kind of focused a little bit here or talked a bit about how we have this entity health item right here and these 4 sub-items that exist for every single class that we're looking at. These have to do with availability, configuration monitors, performance and security monitors, and so on. And we have a couple of monitors here that actually provide useful information and several roll-up and aggregate monitors that exist here as well. All of these roll up to this single entity health monitor that exists right here. So any change in a monitor below this will be represented by a change in this monitor. We'll talk more about how exactly this works in the module coming up. Let's say then for this monitor that I want to take a look at its properties to see if indeed it will generate an alert. Right over here under alerting, we're actually not generating alerts for this monitor. And so when this switches from green to red, we're not going to end up seeing an alert there in the alerts view that relates to the fact that this particular monitor has made that change. If I want to make this change, the way in which I do so has to do with an override. And so let's now configure an override here on the monitor for all objects of that class Health Service Watcher agent. If I wanted to, I could even constrain it down by a group. So for that RDS servers group, I could do so here as well. In fact, let me just do this here. And for these RDS servers, let me now take a look at the different configurations I need to modify. First here is the item generates alert, which as you can see here is set to false. I'll set this here to true so that it does now generate an alert whenever a problem occurs. I could also alert then on what the state of the monitor will be. In fact, if I move things over here and scooch this up just a bit, I can make myself a little bit more room so that I can see what the override value would be. I have the choice of choosing the critical health state or the critical or warning health state. So green versus everything else or green versus red. Let's say I'll choose this to the critical health state here, and I'll say that the alert priority when that occurs is pretty high priority. I mean, if the server is down, there is some work that needs to be done pretty quickly. And so these are the different configuration changes that I could make that relate to how I then position that alert there in the alerts view. Once I've done so, once I've added this into the DEN RDS Servers Management Pack here, if I have all the further configurations made there in the alerting piece, so the notifications piece, then I know that I'll receive this information then on my users' pagers and email inboxes and via whatever mechanisms I've configured. And so down here under Close, once I've made this change, I may want to come back here under Administration for that subscription and make a change here to the properties of the subscription. Specifically right here under the criteria, I may want to adjust, for example, that the monitor I'm interested in has been raised by an instance of a specific class and is of a specific priority. So this would allow me to then identify that for that Health Service Watcher agent, for example, so Health Service Watcher agent, when I do end up getting an instance of that class, which would be any of the machines in that group, well, then I do want to get notified whenever that occurs. This now constrains that monitor to just those servers via that class. And if I choose next and next and next and finish again, that now changes or further constrains the subscription that I've configured here. Now that we made this configuration change, let's actually see what happens if we do then power off one of our machines. I've actually powered off RDCB and fast forwarded things just a bit so that we can see the results of the work that we've done here so far. We obviously won't see the notification because we don't have instant messenger or email, but if I do see an alert, that means that I have made the appropriate configuration change. Let's come back here under monitoring, and first let's look at our up-down state for our RDS servers. Yep, RDCB is now set to critical, so we know that indeed this machine has been powered off. But what I'm looking for here is the further configuration change here under active alerts, which says right there, system.health.entitystate for RDCB is set to red. This lets me know, in addition to these other configurations here, that we have a heartbeat failure and we have failed to connect to the computer. This lets me know that the specific monitor on which I've turned on these alerts, that monitor is indeed sending an alert right over here into my list. In addition to that monitor, so that's a top-level roll-up monitor, there are other monitors that also provide further information about the health of this machine. We've seen these already, that being our Health Service Heartbeat Failure monitor, and right over here, our Computer Not Reachable monitor. In both of these cases, if you look at alerting, you can see that they are already generating alerts here for this monitor. And so we do already have, in the case of a server being down, some alerts being generated here into the interface. But this does provide a great example for how you might go about making some alterations if you don't find the amount of information that you really require. I do want to show you, though, that in order for us to get this information, it actually took a bit of time between the period when I shut down the machine and when it ultimately saw here as critical. One thing you may want to adjust if you have need to speed up that process is something that happens right down here under Settings. For those alerts that have to do with whether or not you've received a heartbeat or not, you can actually make some changes to how often your clients will heartbeat here with your Operations Manager server. The first of which are your agent heartbeats right here, which are set up for an interval of 60 seconds. The second right here are your server heartbeats, which allows 3 missed heartbeats to be allowed before we start recognizing that a problem has occurred. You can dial these down to speed up that process of going from green to red. But again, if you have lots of servers that are all contacting your Ops Manager infrastructure just that much more rapidly, well, you just want to make sure you plan for that in the performance department. But this does give you one way in which you can speed up that process here by adjusting the configurations here under Settings. Now, I want to spend just a very quick minute here on company knowledge, not because it's not important, but it's relatively also self-explanatory here. Obviously, there are some situations where when you make configurations, you might have specialized situations that are only relevant to your environment. In those cases, there actually is a tab over here under monitoring where if I come back to, for example, an active alert here, let's take a look at that alert that we have now newly generated here in the list. If I view properties, right over here, in addition to the product knowledge, so this is what comes from the generator, the creator of the management pack, there is also another tab here for company knowledge. This company knowledge is related to you and your environment. And out of the box, there's going to be no company knowledge. This is only what you have entered in here. If you do choose to edit the monitor, this will bring up the properties then of that monitor, which will expose here the company knowledge tab and allow you to enter in additional company knowledge here, there into the management pack by hitting the edit button. This will launch Microsoft Word. And if I fast forward things a bit and tab over back to Microsoft Word, which launched in the background, you can see the items that now exist here. So right here is where you can enter in summary information, configuration, causes, resolutions, additional information, and external knowledge sources that provide the administrator just a bit more information about what to do when this alert arises. You may not find yourself populating these all that often. It is quite a bit of work here to enter in all this information. These usually come in handy just in those certain circumstances where you know what the resolution is, and you just want to make that available for a quicker resolution the next time the alert arises. Two further very short topics here have to do with maintenance mode and maintenance schedules, which are, as they might imagine, or as you might imagine, a way in which you can tell Operations Manager to ignore anything it hears from a server that is going through a planned outage. Back over here under our computers up-down state, or perhaps our Windows computers view here, you can see now the list of machines that exist, and my RDCB machine indeed is still down. If I were experiencing a problem here with this machine, and I was going through some kind of planned maintenance that involved an outage, rather than just turning off the machine, I may want to enter that machine here into maintenance mode. Turning this to maintenance mode will essentially disable all these alerts and prevent people from seeing an alert storm there on their pagers or inboxes or what have you. I can apply it to the selected object only, so just this object here in the view, or the selected object and all the contained objects as well. In the case of a planned outage, usually it's a good idea to do the selected object and all the contained objects because you don't want some configuration to inadvertently then set up an additional alert that you weren't expecting as you were going through the change. For the category here, I have several different options for unplanned outages, or I could just set this up as a planned outage. Most often in these cases, whenever you're configuring maintenance mode, you will set this up as a planned outage. Although in certain circumstances, when an unplanned outage occurs and you just want to shut off all of the Operations Manager alerts as you're fixing the machine, that is the reason why you have all these different other configurations here for unplanned outages. For those very long unplanned outages, it can be really great for your fellow coworkers when you're not alerting them as you're going through the troubleshooting and resolution process. I can pick here whatever my category would be and then a comment. I can also choose what the duration would be, so a number of minutes or a specific date and time, and then go about then temporarily suspending any Ops Manager efforts then having to do with this machine and the object that we're working on. I'll hit cancel here because I don't want to turn on maintenance mode for these machines, but this is the way, once you start turning on all those alerts, that you ensure people don't get alerts on computers where you have a planned outage going on. In addition to the planned outages, are also a way in which you can set up maintenance schedules. So if you know that a machine is going to be down for a period of time in the future and regularly, perhaps once a month for the application of patches, you can set up a maintenance schedule to ensure that Ops Manager automatically shuts down the notifications on that machine during that period of time. If I come here to maintenance schedules, one of the first things I'll need to do is to create a maintenance schedule, which again allows me to identify the selected objects and their contained objects here. For this, let's search on one of our machines. So RDCB, for example, is being the one that we want to set this outage schedule for. This is a great place to set up these schedules so that you don't get notifications on any of the classes for which you're performing monitoring. If I choose next down here, I can set what the schedule should be, what the maintenance mode will be once, daily, weekly, or monthly, what the duration, and then when it is effective, and then any details that I want to provide here as well. So essentially just setting up the actual schedule here like an app job for turning on maintenance mode for one or a set of machines. As with seemingly everything here in Operations Manager, the hardest part is the targeting, trying to figure out exactly which alerts that you want to then pass on through some alternative channel. What have we talked about in this module? We've gone through, in addition to that, all the different steps that need to be laid in place so that you can then get those appropriate alerts then sent out to people wherever they may be. We began first with a look there at the channels, so the ways in which you distribute out these alerts, then into the subscribers, the who, and the subscriptions being the what. From there, we then dug in just a bit deeper into the specific alert configurations and how you might adjust those there for rules and monitors, really taking a look at the use of overrides for any kind of rule and monitor that exists in a sealed management pack. We also use this as one more way to kick off our next module there in the configuration of rules and monitors, and how we can also set up our own custom alerts once we have that full flexibility of generating them on our own. We look there very quickly also at populating company knowledge if you do have some specific information you do want to relay, and then concluded there with enabling maintenance mode and setting up maintenance schedules so that we don't end up notifying users when we're doing those late at night planned outages when everyone else is asleep. Coming up next, we've made our way now to the customization of our own rules and monitors. We have here to this point explored really all the different facets of the configuration of an existing rule and monitor that comes as part of a management pack we've downloaded from some third party like Microsoft or another company. But there are circumstances where you don't actually have a monitor or rule that you require that exists in one of those MPs. In those circumstances, you need to create your own, and that really is the entire topic of the module coming up. In that next module, we'll go through the creation of rules and the ways in which we identify what needs to be monitored, as well as the customization of a monitor and how we define what is the good state versus what is the bad. That actually pretty cool conversation on the customization of our own rules and monitors is a topic for our next module coming up. We have actually here to this point gotten pretty far in our exploration of Operations Manager and its use here in monitoring Windows Server 2016. But we have one limitation in everything we've talked about here so far, in that everything we can monitor has to exist in one of those downloadable management packs that you grab from somebody else. You will probably find at some point in your exploration the need to then monitor some custom application, or even an app that you have that doesn't include its own management pack. When that situation arises, it becomes necessary to customize and create your own rules and monitors for figuring out exactly what those behaviors are when they're not already included in some management pack you can find somewhere else. Our conversation here in this module really only scratches the surface, even with this long number of topics, in terms of customizing your own monitors and rules, and also really creating your own management packs. That process of authoring your own MPs includes quite a bit more code with XML and script requirements that go far beyond what we can talk about here in this course. What I want to do here, though, is I want to kind of set the stage for how you can, right here in the interface, go about creating your own monitors and rules for a few specific use cases, and then turn you loose for the much more advanced and complicated mechanisms that do require additional code. Here in this module, we'll start by taking a look at the differences between monitors and rules. There are very important differences in terms of when you would use one versus the other. And then from there, we'll focus in on one very quick visibility section that we haven't really talked about here so far. In everything we've discussed here, it's actually been kind of difficult for us to really get a feel for the membership of any particular class, or also what we call a target. And so I'll show you one quick way in which you can very easily see what exists inside any particular class or target that you need to find out as you go about now creating these monitors and rules. From there, I want to go into 4 use cases for different kinds of monitors and rules that you may find yourself needing to create. These are only 4 of the many different types of monitors and rules that exist as you start tooling there through the interface. We'll start first with an event collection rule, which is a way in which you can gather information right out of the event log for a machine. These event collection rules don't necessarily generate alerts, and so I wanted to show you this particular use case here because in some circumstances you may just want to gather the information without it actually generating an alert for letting you know that something has gone wrong. There are also alert generating rules as well that have to do with event log and event log entries, so once you understand how the collection rule works, you can then modify it to the other types of rules that will generate their own alerts. We also want to talk about configuring performance rules. These performance rules are what allow you to then gather performance data and then visualize it there inside of some view. These 2 are the 2 rule-based use cases we want to talk about. We also want to talk about some monitor-based use cases as well. Of these, one of the easiest to implement is a Windows Service Unit Monitor, which quite literally just looks to see if a Windows service is up and running or not. We will implement this Windows Service Unit Monitor, in fact all of these different monitors and rules, against that RDS implementation that we've been working with here so far. Once we then know that the appropriate services on our RDS servers are working, we then want to take a look at a Performance Counter Unit Monitor, which is a special type of unit monitor here, very different from the performance rule, and that this will give us the abilities to change the state of our RDS environment when some performance counter, one that we'll talk about here, exceeds a certain threshold. So this will give us a red versus green dot as opposed to a line graph that shows us the historical values for performance. Once we do those configurations, then we can also configure diagnostic and recovery tasks for a monitor. I mainly here just want to show you that they exist and where you might go about configuring them. If there is any situation that you're looking for via either a monitor or a rule, you can configure a script or a command line to perform a diagnosis on the problem or even recover the problem if it's something that you are aware of and can fix, again, with that script or command line. Lastly then are the aggregate and dependency roll-up monitors that we've seen here so far. These are the ones that we see underneath that entity health item that exists there in the authoring view. These roll-up monitors, by virtue of their name, can roll up the picture of health from one level to the other, and are used in different circumstances when you have different kinds of monitors that you want to roll up to one single verification there of health. At least at this point in your exploration, you won't find yourself actually creating these types of monitors all that often. You tend to use them more when you go about creating your own management packs there from scratch. But for our purposes here, I want to give you a feel for what these are and where they become useful, and again, rolling up that picture of health from one level to another. Now, the idea of these monitors and rules at this point should be nothing new. We've been working with them and overriding them here really throughout this course. But at this point, I want to talk very specifically about what the monitors and rules are, especially the differences, why you have one versus another. And so let's take a look here, not so much at the monitoring view, but rather down here in the authoring view, where we can start digging into the individual management pack objects that exist in those we've downloaded here so far. Well, let's start first here with the monitors, where we can take a look at just some of the monitors. I've scoped things here to just a couple of the role services associated with RDS, so that we can see the kinds of monitors that have been downloaded as part of that MP that we brought down for remote desktop services. Let's say, for example, for our remote desktop connection broker role service, here under Entity Health, we have the 4 different aggregate roll-up monitors that exist here for every single class that we're working with. These are availability, configuration, performance, and security. And these are, as I've said already, here just to separate out the different types of monitors in terms of what they're intending, or really what behaviors they're intending on reporting on. Here you can see a variety of different availability monitors here that do things like checking for personal virtual desktop availability and the RD connection broker availability. For any of these, you can actually get a look at them by double-clicking on them to view their properties, where you can see here what the target is. Again, this is the RD connection broker role service, what we're viewing right up here. And then for this, what we consider to be healthy versus unhealthy. Here you can see when the first event is raised, we consider that to be critical, with the second being a warning, and then a manual reset here, setting it back to healthy. It's then right here under alerting where we see the actual alert value that occurs once this monitor shifts from green to one of the other values. So here you can see the data and the context and the description of what the event description is. This is what will appear then in the alerts view over on the monitoring tab once that does shift from green to red. It really is right over here under the configuration pane where the actual configuration of the monitor exists. And it's here where much of what you see will not actually make much sense until you dig fairly deeply into the creation of your own management packs and the configuration here of the XML that makes up certain types of these monitors. So you can see here that if I choose view here, the configuration is actually a very large XML file that if you kind of parse through, you can figure out some information about what it's looking for. Like, for example, the log file, Microsoft Windows Terminal Services Session Broker Admin, which is included right down here. In that log file, we're looking for event display numbers, or event numbers here, equal to, for example, 898. Down here also for 901. And we have some further information down here as well that we're looking for, like the second log here for our Session Broker log. Again, much of what you're seeing here involves a level of XML that goes beyond what we want to talk about here in this course. But as you start poking around these different monitors, you'll start to see similarities in how the different XML files are configured. Many of these monitors are actually just looking for event log values that pop up in the event log to use that as the recognition that some bad behavior is occurring on a machine. However, not every monitor is set up via some complex XML configuration like what you see here. Other monitors actually use different mechanisms in order to identify what exactly they're looking for. So right here, for example, we have RPC configuration, which actually uses an event log tab here to help you know which event log contains the information that this monitor is looking for. Right here, we're looking for Microsoft Windows Remote App and Desktop Connection Management, and then the admin log. And then right over here is the event expression, which says when the event ID equals 1003, well then, as you can see here under health, go ahead and set this from green to yellow. This is obviously an event log-based monitor, which is the core of many of the different types of monitors you'll find yourself later configuring. So this should give you a feel for one of the different types of monitors we can use to dig into the event log in search of the specific event log values that let us know that a problem is occurring. But this is not the only type of monitor that you can configure based on event log values. You can configure other types as well, like a basic service monitor here. Here we're taking a look for our connection broker service status, where once again here in the RD Connection Broker World Service, so this is the class, right here is the service that we're looking for. I mentioned that we'll be going through an example of creating a Windows service-based monitor here in a second, and you can see here that really this is pretty easy to configure. This is the service name that we're looking for, and right here is the health value. If it's not running, we have critical. If it is running, we're healthy. For many applications that exist on your Windows servers, if the service isn't running, well then that's definitely a problem. And so configuring these different service status monitors is a great way to help you understand why that application isn't working at any point in time. These are obviously the monitors. We also have the rules that exist down here at the bottom. These rules, as you can see, I've got 3 of the 6 different RD-oriented classes that exist here. I actually am scoping this to all 6 or 7 of them, but only 3 actually have active rules assigned. If I take a look here at, for example, the virtualization host role service, we can see here a couple of rules that relate to measurement of performance. So here is your host servers running virtual machines, and here are your host servers with stopped virtual machines. Our rule here, as you can see, is targeted to the Remote Desktop Virtualization Host role service, so that class. And then right up here is the configuration for the rule. So what is your data source, and then what is your response down here at the bottom? For the data source, this is the performance counter we're looking for, so Hyper-V virtual machine summary with the running counter right here. And then right over here is the response. So when we do end up having an issue, what will the response be? So the performance data collection write action, and then the performance data publisher right down here. For these, we're using our run as profile, which I believe is our management server action account. So that's the account that's actually performing these tasks there on that agent, with the information that it gathers then brought back here into our Ops Manager infrastructure, stored there in the database, and then made available back over here under the monitoring view when it comes time to actually run these performance charts that exist there under the Remote Desktop Virtualization Host role service class. Now we don't actually have, I don't believe, a view that's been configured to view this information, but here in just a minute as we go through the custom creation of these monitors and rules, we'll actually then create also the items that are required over on the monitoring side so that we can see the results of the information this rule is collecting. This rule is not the only type of rule here. This is obviously a performance rule, but there are others that exist. Here under the RD Session Host Role Service, we have a couple of baseline collection rules that exist here. And also up here under RD Gateway, it looks like we still have some performance measuring rules that exist here. Well, these are the ones that are configured here in the RDS Management Pack. They're not the only types of rules that you can configure. So here in a second, we'll talk about what those rules are and how you can go about configuring them. Before we do so, though, I want to talk a bit about really the differences between the monitors and rules, because you will want to create different types of objects in different circumstances. I've talked already about how a monitor is different from a rule in that the monitor affects the entity state. When we look at the difference between a green versus a red value for the health of an object, that actually comes from the result of a monitor. This is different from a rule which will not affect the entity state, that red versus green value. Monitors also auto-close alerts when the conditions are resolved. We talked earlier in the views about setting up that is monitor alert column when you're configuring an alert-based view, because you don't actually want to go and resolve a monitor-based alert. That's the case because those alerts will auto-resolve themselves, auto-close themselves once you go about fixing whatever problem that monitor is alerting on. This is different from a rule where with the rule, the rules don't actually auto-close the alerts once you've solved the problem. You need to go through and resolve and close that rule in order to get it out of the view. This is the case because your monitors have both a repeatable start and end point, whereas your rules do not. Your rules, just like your monitors, can constantly be verifying whether or not the machine fits within the parameters of the rule. But once it actually trips that threshold, well, then the threshold has been tripped, and there is no capacity to then self-heal that situation without resolving and closing the rule. This is the case because your monitors tend to focus then on established state, so whether it exists in one state versus the other, versus whether or not it has actually gone through the threshold of the rule that you've created. Lastly, and as this is particularly important when you're talking about performance data, is that rules can do different things than monitors can do. A rule can alert on and also collect performance data from a machine. We've seen an example of this in all the rules that are currently there for RDS machines. This is different from a monitor, which can alert on performance data, but not collect that performance data. You will not be creating charts and graphs out of performance data by configuring a monitor. Rather, to do that, you'll need to configure a rule. And so with this, we'll actually configure a rule to do that performance-based charting of data, and also create some monitors to show you exactly what those types of objects can do. But before we start creating these rules and monitors, I want to take a step back and talk a bit about a way that we can easily visualize the contents of these classes/targets that we've been working with. I will freely admit that I've been using the term class and target interchangeably here throughout the course, and for the most part that's actually okay because the target for anything we're creating is the class that contains the instances of information that we're looking to visualize. Back over here under monitoring is where we can see an example of that. If you recall earlier, right down here we created a view for our DEN RDS Web Access Server Health, where if I right-click and choose properties, you can see that the class that we actually targeted for this view is Remote Desktop Web Access Server Role Service right here. This class, this target, contains instances, and those instances are what we see here in the view right here. But throughout none of this course have we really gotten a good, easy way to sort of browse through all the classes to figure out what they contain. I want to show you here that there is a special view right up here called Discovered Inventory, which is a really handy way in which you can identify the contents of any class. You do so by right over here choosing the Change Target Type item, and then identifying which of the common targets or all targets you want to view. Let's say, for example, that if I view all targets here, I can take a look at the remote desktop right here, remote desktop, services, session host role service, which would give me ostensibly the RDSH machines that are currently plugged in here into the environment. If I hit OK here, indeed, I do see rdsh.company.pri. But I could change the target type to something else entirely as well. So let's say, for example, IIS, to get a feel for our IIS-10 websites that exist. This will be all of the IIS-10 websites that exist on all the machines across every agent here in the environment. And for that, you'll see we have two. One on MGMT, which is the website here for Operations Manager, and then right down here is one for RDS Web. Each of these classes, although they're viewed here in a flat table, actually are contained within other classes. And so there really is actually a hierarchy of classes that exist, each containing the other. If you want to look at the very top level class, the very top level class to look at is actually Object. If I look at Object here, this will be the top level class from which everything else actually exists. And so this Object class right here includes all the objects that exist here in our Configuration Manager infrastructure. And so I can scroll down here and see all kinds of different items like Azure SQL Cloud Services. Here's default website for pages. Right here are our Windows Server Instances Only group, and so on and so on. Each of these, if I view the item here, if I single click, will give me the full path name for what this instance is and what class it actually belongs to. And if I scroll all the way down here to the bottom, you'll see those that are actually monitored and are also healthy. So right here, .NET v4.5, this MGMT server contains an instance of this class for .NET v4.5. And then from there, I can continue drilling further down to see, for example, the Health Explorer for any of these objects. So if you haven't actually seen this before, this is a great way to get a better feel for what is contained inside each of these classes and targets that you've been working with here so far. and becomes extraordinarily handy as we get further into the configuration of these rules and monitors coming up next. Let's now assume that for this RDS environment, we have some monitors and rules that don't exist in the existing management packs, but that we need to configure so that we can be aware of certain behaviors on those RDS servers. I will freely admit that the rules and monitors that we're about to create here are already represented in the existing management packs in certain ways. So what we're doing here is not necessarily net new, but I wanted to show you some examples that already exist so that you can get a comparison between what Microsoft is providing and then what you may later want to provide as you start creating your own. Let's start the process here by creating a special type of rule called an event collection rule here. An event collection rule is a special type of rule that doesn't actually generate an alert. And you can see here that this is identified here by the difference between an alert generating rule and a collection rule right down here. A collection rule, and specifically this event-based collection rule we're about to configure here, is designed when I just want to gather the information from the event log so that I have it in a certain format. I don't necessarily want to generate an alert based off of what it sees, but just rather to have that handy in case I want to find out information in a single location about the behaviors going on this machine. And so let's take a look here at the NT event log. And in fact, there is a particular area in that event log that I want to set up this collection rule for. Let me actually bring up the event log here, or the event viewer, and then refocus the event viewer not on the local machine, but rather over on our other computer. That would be the RDSH machine we're working with. Here in this RDSH machine, let's take a look at the different applications and services logs that exist. Right down here are those specified logs for each of the roles that are on that machine. And here under Microsoft and Windows is where I can find the different logs that are associated with the terminal services part of remote desktop services. So right down here under terminal services, right down here at the bottom, are a number of specialized logs that contain operational and administrative information about the running of this RDSH server. Let's say that I'm interested in collecting each user when they log in and where they log in from to give myself a nice list of which users have logged into this machine at what point in time. This information, once collected, will end up inside my Ops Manager database, and so that I can have it for archival purposes for later review. I happen to know that the information I'm looking for is down here under Terminal Services Local Session Manager, and then right down here in the operational log, I should be able to find the event values that I'm looking for. In fact, right here, it's event ID 21 is the one that I'm looking for. Right here, event ID 21 shows me when an RDS session logon has succeeded, and it includes information like the username, the session ID, and the source network address for the person that's actually logging in. With this event collection rule, I can collect any instances of this event and store it here in my Ops Manager database so that later on I can create a view to visualize who's been logging into my RDS environment. So let's use this information here to actually generate then an event collection rule. I will store this into my DEN RDS Servers Management Pack here, and let's call this rule Collect User Login Information. The rule category here will be an event collection category, although you can see all the different options that exist here. And the rule target will be the machines that are hosting the RDSH service. So those that are actually in the, if I move up here, that are in the remote desktop services right here, remote desktop services session host role service, so that RDSH role service. We saw just a second ago that there is only one machine in this environment that's in that role service, and so that will be the machine where we'll collect the information. Down here under our next is where we can identify which event log we want to read the events from. It will not be the application log, but rather right over here on RDSH, it will be our Terminal Services Local Session Manager log. So I need to scroll down here and actually extend this over to find our Terminal Services, way down here at the bottom, Terminal Services Local Session Manager log. So if I can scroll up and find the right one here, Terminal Services, and then Local Session Manager. If I scroll this to the right again, I'm looking for Terminal Services Local Session Manager / Operational, because that's where this information is contained. Let me hit OK here, and in the next screen over here, identify the event expression, essentially which events do we want to gather there out of the log. As you can imagine, we want to make sure that we constrain this pretty well because we don't want to end up filling up our Ops Manager database with a bunch of events that we don't care about. And so here we're looking specifically for event ID 21 and a specific event source here as well. This event ID 21, as we already took a look at, is right here. So this is a successful login of the user, the session ID, and that source network address. When you are looking for the source, though, right down here, you might assume that this is the source that you need to plug into Ops Manager to correctly identify which events you're looking for. But rather, this is not actually the correct syntax for that source. To get access to that, you'll need to come over here to Details and then the XML view and actually gather the source right here from the provider name. So you'll notice this includes Microsoft-Windows before Terminal Services Local Session Manager. So let me copy that here to the clipboard and then enter this in as event ID 21 and then Microsoft Windows Local Session Manager as that event source. That now creates the rule. And so this will begin gathering that information from those RDSH servers and storing it here into our Operations Manager database. Our next step then is to actually go about creating a view so we can see the information that we've gathered from those machines. Let's go back over here to our monitoring view and create exactly that view that we need. I'll come back over here to our DEN RDS servers and create a new view here, which will be an event view. This is not a view I think we've actually created here up until this point. So let's call this DEN RDS servers successful logins. I do want to constrain it down, so I'm not interested in all the information by setting it here to object as the target, but rather let's retarget this back over here again to our RDSH machines. I'll punch in remote here and scroll down to get to our session host role service target right here, and then further limit it to only the information that's been generated by these specific rules. I need to look here for the collection rule that I just configured, which was collect user information. Right down here, I should be able to find, right here, if I scroll down far enough, collect user login information right here. If I hit OK and OK, this will now go about creating the view. While this view is getting created, let me go ahead and then log in to our RDS environment so that we can see exactly how this might look once I have information here about a login to the environment. Let's go to rdsweb.company.pri/rdweb, where we can log on here to rdweb and get access to that calculator application that we configured way back during the original configuration of this entire environment. Once I log in here to calculator and it does the initial login, I should be able to see the calculator application because, well, our RDS environment is set up to do that. Once that then is done, I should be able to come right back over here and then refresh the view to get information then about the login, the successful login here to this environment. And so, yep, there is my information. There is the value there. There's all the information that we saw before, the username, the session ID, and the source network address. And here now, as the agent continues to gather further information about those logins, they will end up here in this view so that we can see which users have logged in to our RDS environment. Our second use case will be the configuration of a performance rule. As we talked here already, performance rules are used to gather information so that we can build a nice chart and graph about historical performance of a server or service. This is different from a monitor, which we'll also create in a second, which is more about defining what the health is of a particular system. We want a chart and or graph here, so let's go about now creating a performance-based rule. I am still back over here in the authoring pane, and once again, or really let's continue here with our session host role service. For this, let us now create a new rule. This rule will be a collection rule once again, but this time it will be a performance-based rule that will be gathering Windows performance information, essentially stuff that you get there from perfmon. I will again put this down here in my DEN RDS servers management pack right there, and then let's give it a name. So let's call this a % processor time for RDS servers. And I'll copy that to the clipboard so I can use it later. We'll still use this as a performance collection rule category and target it to those machines that exist there in that RDS session host role service class. If I hit next down here, it's here where I identify which perfmon counter I'm looking for. And I've found it easiest to actually just hit the select button down here to use this nice little wizard to identify which perfmon counter you're looking for. Let's change things over here to RDSH, and let's go down here to the processor counter. The processor counter will include all that information about processor use, like our % processor time counter right here. I can identify instances if I want, or just the total amount of processor time. We'll keep things easy by using just the total time here, and then specify what the interval will be. Down here you can see 15 minutes, and as with any of these collections, anytime you reduce the number of minutes, you're going to increase the amount of data that you're going to need. I'll put this as 5 minutes for this example, but again, in your production environment, you want to be very careful about how often you're gathering this information. Let me choose next here to include that information into the rule I'm creating. And it's here where we have a very important decision about how much data we really do want to collect as we're bringing this information in from that machine. Anytime you're gathering perfmon-based information, there is the possibility of gathering an extremely large amount of data. And so here for these performance counters, we have the option of choosing either high optimization or low optimization, which is effectively just a bit of calculus here that allows us to gather less information if the tolerance for the quality of that information is high. So if my interest in this performance information is really about the generic performance, meaning that if it waves around between a few percentage points, I'm going to be okay with the result. I can choose to use optimization or high optimization. Although if I'm looking for very specific performance information, I want to do then the low optimization over here. This is going to take more bandwidth, stores more data there in the database, but it does give me a more actual view, a more real-time view of the performance counter that I'm measuring. And so if you have machines where it's extremely important to know at all times what those performance counters are, and you don't want to sort of smudge them together to reduce the amount of data you're collecting, you'll want to choose low optimization. In this circumstance, I'm more interested in knowing just the very large swings when these RDS servers end up consuming too much processor time. So I can choose high optimization here and then set an absolute number or a percentage value here for what my tolerance will be. I'll set this as an absolute number here to 5 so that, again, I reduce the total amount of data that I've got to transfer and then store. When I hit create here, that creates the performance collection rule. And as before, I now need to create a new view where I can then visualize this information. Let's do that once again over here under monitoring, where we'll go back here to our DEN RDS servers and create a new performance view here. So let's call this, again, percent performance time or percent processor time for RDS servers, and constrain things down once again to those RDSH machines. So remote here, show all targets, and then as before, scroll down to set this to our remote desktop services session host role service right here. Once I've done that, as before, I will do so by using the information collected by specific rules. And then here under the specific rules, I want to find the percent processor time for RDS servers rule that I configured just a second ago. If I hit OK and OK here again, this will create the view and will ultimately let me then visualize the information that I've gathered there as part of this rule. That process might take a few minutes for it to gather the necessary information, but after the view gets created and then populated with information, we should then be able to see what the percent processor time is for any of our RDS machines. Right here you can see that we now have the new view. There's percent processor time. And if I fast forward things really several minutes here into the future, you'll now see that we have some data that we can take a look at. Right down here, once we have the data, we'll have the abilities here to check the checkbox for processor time and actually visualize that processor time here in the graph. If I fast forward things again, we'd start to see actual data here, but you can get a feel here for exactly the kind of information we're going to get as we start collecting more percent processor time metrics here from this machine. Now, I wanted to start here with rules in this module because we have been spending so much time with the monitors, taking a look at their state and how they affect our picture of health. These rules are very different. As you can see here, there are very different views that we get out of the data that we collect here from rules. And in fact, these aren't the only rules that are out there. I'll leave it to you to explore the many different kinds of other rules that exist out there, especially those that involve things like timed commands or even probes, which invoke scripts to accomplish certain tasks. For all intents and purposes, if the data you're looking for is something that you can gather via script or a command line, it's something that you can encode here into a rule. But obviously, these rules are only one half of the different ways in which we can monitor for different behaviors on our servers. We also have the abilities to create monitors. We have worked with these before, but we haven't actually created our own monitors just yet. Here I'm back in the monitors view where I've got all 6 of these different targets that exist. And for each of these targets that I have, you'll see down here under entity health that each actually has at least one, if not more, different monitors that are already created here as part of the management pack. So these are the ones that come down as part of that MP. They're installed here during the installation of that MP. But let's assume that perhaps the monitors that we have don't exactly capture the behaviors that we're looking for. When that's the case, we need to then obviously create our own. So let's scroll this up here and go back to our old friend, the RDSH server. And then here under availability, go about creating a new monitor for, let's begin with perhaps a Windows service monitor. The first type of monitor that we're going to create, which is the one that really is the workhorse behind all the monitoring that you're doing, is what's termed a unit monitor. I begin that process by either right-clicking over here or by right-clicking over here on the class. If I right-click over here on the class I'm looking for, it will auto-populate the class information when we get to that page here in the wizard. As you can see here, there are a large variety of monitors that can be created, and all of these really have to do with that definition of health, so defining what the state will be for the server in relation to the behavior that you're looking for. You can see things here like SNMP monitors and WMI performance counting monitors. We can peer into log files to see if certain information exists or does not exist in those log files. We can also do things like Windows events. One very easy monitor to begin with is a basic service monitor. And it's easy because if the service is running, well, then the server is healthy. But if it's not, then we end up with that big red angry X. Well, let's assume that we want to create a new monitor and target it to our RDSH servers that will let us know if the remote desktop services terminal services service is actually not running on that machine. Let me go here and then add this to our DEN RDS servers management pack, just like we've been doing for everything. And let's call this the Term Services Service Availability Monitor here. As I told you, the monitor target's already been populated for us. This is the RDSH role service here. And down here, we can choose what our parent monitor will be. This, when you create the monitor, really is your decision as to whether or not it is an availability, configuration, performance, or security monitor. And really, it's up to you in terms of which of these you enter it into. Because this has to do with whether or not the service is running, to me this seems like an availability monitor, so I'll add that as the parent monitor. And I'll select this here so that the monitor is enabled as we create it. Right over here, if I hit next, we now need to identify which service that we want to then monitor, which will be the actual terminal services service that allows users to log into that machine. As before, I'll come back over here, go to RDSH, and then locate the appropriate service, which I believe is the remote desktop services right here, term service. So that's the actual service name if you take a look at it over there on the machine itself. It is this service that we want to monitor, and very simply, we're looking for whether or not it is running or not running, which will determine whether or not the health state is healthy or critical. And if I choose next down here, I can choose then what the alert settings will be when we go from green to red. This is optional. You don't actually have to pop an alert whenever you do make that move from green to red. If you do, though, we can generate an alert here for when the monitor is either in a critical or warning health state, and then choose what the name, priority, severity, and text of the alert will be. So you can adjust these based off of how you want to be alerted for this particular condition occurring. The alert description down here, again, allows us the option to populate the value here with just information that makes sense about the alert. And as before, we can use these variables to populate it with information that's coming from our Ops Manager database. So the object status, the notes, the display name, and so on. This gives me the target information as well as the data for what actually is happening here on the monitor. So it's essentially a variable that gets populated from information there inside the database. I'll just leave this as the regular value here, but you can work with this to figure out exactly what your value should be. Once you finish it, we can choose to then create the monitor, and as you'll see, that monitor will get added here to the target, to that class that's associated with our RDSH servers. Once that monitor gets created, we should find it down here in the list of those that are here under the availability roll-up. And if I scroll down here, I should see it right there. There's our Term Services Service Availability Monitor. Actually visualizing this then requires us, as before, to have some mechanism, some view there in the monitoring pane so that we can see then the health of any of the machines, any of the instances that exist here under this class. We don't have that yet because we haven't created such a view. Let's create that view here again under DEN RDS servers. And I'll do this as a state view, just like the other state views that we configured before. So let's call this DEN RDSH servers, so Remote Desktop Services Session Host Servers. When we do that, we want to show data not related to all objects, but rather over here to, once again, the RDSH machines. We've already done this a couple of times here, so all I need to do is then scroll down and find that remote desktop session host role service. What this will give me is all the information associated with health for these particular instances that exist there inside that class. So I'll choose yes over here. I'm not interested in doing specific conditions, but I am interested in all the data there. I don't want to limit this by any particular group, although I could limit it to my DEN RDS servers because I've already created that group back on that earlier module. If I choose OK here, after a second or so, the view will get created, and once all the internal processes have been completed, we should then see a view, a typical state view of this machine, which is rdsh.company.pri. And in fact, there it is. There's our healthy view of this machine, RDSH, and we now know that we have the view that we're looking for. Let's validate whether or not the statement of health also includes the monitor that we created just a second ago. I'll right-click here under Healthy and choose to open the Health Explorer here for RDSH and remove all the monitors, and take a look here under Availability to see if that monitor exists. There it is right there, our Term Services Service Availability Monitor. It's currently set as green because we do indeed know that the Terminal Services service is currently running. In fact, I still have a copy of Calculator existing here on this desktop. So this should give you a feel for how you can create your own monitors and insert the information you're interested in, the custom information, directly here into this statement of health like what we're seeing here. If it doesn't exist in an existing management pack, you can use this mechanism to create your own monitors and monitor what makes sense for you, your services, and applications in your environment. Let's take a look then at a second example monitor that we can create, and we'll associate it again here to our RDSH machines. Earlier, we created that performance rule, which allowed us to actually take a look then at the performance over time. But sometimes we're not interested in the historical performance. We want to be alerted if performance exceeds a certain threshold. So let's now create that performance expectation as a monitor as opposed to a rule. Let me come back here under Authoring, and then once again, we'll go back over here to our RDSH session host role service. And once again, we'll go about creating a new monitor here, which is again a unit monitor. These unit monitors, as I said, are the workhorse. They're the ones that actually do the work here in the Ops Manager environment. The Windows Performance Counters monitor right here is the one that we're looking for. And out of them, you can see that we have two different options, either a self-tuning threshold or a static threshold. You can imagine that your environment over time will generally behave in a certain way. And it's when it behaves somewhat different from that general behavior that you know that perhaps something's going wrong. Maybe someone's using too much processor, more so than just the average processor use. In that case, you might configure a self-tuning threshold here, which can be either a 2-state or a 3-state above or below or baselining threshold. So if you know generally that your service tends to exist in a certain behavior, you can use this to let you know when it wildly exceeds those expectations. Or alternatively, and sometimes easier to understand, is a static threshold here. These static thresholds, either a single or a double threshold, allow you to define either an average, a delta, or just a simple threshold or when a certain level of performance, a particular perfmon counter, exceeds the threshold that you define. For this, let's go back to our old friend percent processor time and assume that at any point, if any of these RDSH servers exceed 80% of total percent processor time, well, then we know we've got a user there that's consuming too much CPU and we have something we need to do. So let us create then a simple threshold monitor here and associate it once again with our DN RDS servers management pack. And for this, let's call it RDS over 80% processor time. So this is the monitor that we're creating. We are already targeted here to the RDSH session host role service here. And let's change the parent monitor from availability right down here to performance, because this is a very different type of monitor. If I choose next here, I can then identify which performance counter I'm looking for, which is very much the same as what we did before. I'll go back here to RDSH and then go back down to processor. And once I've identified the processor class, the processor object, and then right down here is percent processor time, the total processor time across all those CPUs. If I hit OK here, that populates all the information here that I require, and I'll reset this again from 15 minutes to 5 minutes with the same caveat there about doing this in production. If I choose next over here, this now allows me to identify what the threshold value should be. I am looking for any time that we go above 80% in CPU time. So if I'm above 80%, here on the next page, I know that above that threshold, I want to set my statement of health from healthy to critical. That means that there's something I need to do, and ultimately that will bubble all the way up to the very top level to let me know that this server is having a problem. The whole point of creating these monitors in the way that we are is so that they all filter up their information all the way to the top level so that we are aware that a problem occurs and can drill down to exactly why the machine is misbehaving. So I set here my under threshold to healthy and my over to critical and hit next. I can also generate alerts for this monitor, which I do want to do, and you can see here there are automatically here some default alert descriptions that include things like the instance, object counter, value, and time information. So this is what will end up there in the alerts view once we do exceed that 80% threshold. Once I'm done, I hit the configure button here, the create button, and that will go about now creating this monitor and associating it also here to the RDSH class. Except this time the monitor should be found here under performance as opposed to under availability. So if I drop the drop down here, right there is our RDS over 80% processor time monitor that we've configured. Because we already have the view though, there's nothing else that we need to configure over in our monitoring pane. All this information, all the monitors and the values associated with those monitors should automatically get rolled up here to our DEN RDSH server's statement of health because they're already included there in the list of monitors. If I give it just a minute or two to allow all those background processes to occur, I should then be able to right-click here and then open up my Health Explorer to see where this monitor exists in that very long list. If I unfilter the monitors here and take a look under performance, right there is RDS over 80% processor time. And in fact, if I hit the F5 button here, I should be able to, yep, there it is, right there. We are now successful in terms of the fact that we're under 80% processor time for this particular perfmon counter. So this gives you the abilities to define a state, an expected behavior that when the machine exceeds the thresholds of that behavior, well, then you get notified that that machine is no longer healthy. Now, while we're here, I do want to spend just a minute talking about one additional tab that exists in the monitor configuration, that being the configuration of diagnostic and recovery tasks. These are special kinds of tasks that you can add to a monitor that you configure. You can also add them to monitors that already exist that can perform certain functions to give you better information about why a state has changed, or also, in the case of a recovery, to even attempt to resolve the problem automatically. Let's go back here to our RDSH session host role service once again and take a look at the monitor that we just configured. Right down here, this monitor is again our term service availability monitor, where if I take a look here at properties, we can see the diagnostic and recovery tab that exists right here. These two are split up into diagnostic and obviously recovery tasks, with the main difference being that your diagnostic tasks are designed to gather more information about the problem that's occurred or why the state has changed. Diagnostics will run after a monitor changes state, and they're there, as I said, as an attempt to collect further information and provide that information in with the state change history and the properties of the monitor. If you do plan on doing something rather than gathering information, you usually want to do that not as a diagnostic task, but rather as a recovery task. In either of these cases, the actual way in which you configure this is more or less the same. It's either run as a command or as a script that exists there in one of your management packs. If you run, for example, a command down here, you need to just enter in the name of the command and then also the command line that you plan on running. In the case of diagnostics and recoveries, you can run it automatically, so it will occur as soon as that state change occurs. And then in the case of a recovery, you can also choose to recalculate the monitor state after the recovery finishes. So this gives you the abilities to then enact the change and then have the monitor re-verify whether or not the problem has since been resolved. Once you figure out what your recovery name should be, and I'll just put one in here so we can get to the next page, the actual thing you want to do here is here in the command line or in the script that you identify. So you would have to identify what your command line or script would be that would then enact there from the perspective of the agent on each machine, and then provide that information back over here into your monitoring pane. If I hit cancel here and back to our monitoring pane, right back over here into the statement of health of the machine. Obviously, these being command line or script based, you really have to have a good feel for exactly what information you want to gather or what action you want to perform. But if you are aware of what the problem is and can run a script against it, this is one way where you can much more quickly provide that additional information or even return the object back to health. Now, our last topic here is one that I don't actually want to spend too much time on, in part because you won't find yourself creating aggregate and dependency roll-up monitors all that often at this phase in your exploration of Ops Manager. As you start building your own management packs, as you start digging into the actual XML for authoring the content of those management packs, you'll find yourself perhaps needing to include either aggregate or dependency roll-up monitors in order to then roll up the health state either among monitors that exist inside a class or across different classes. But for our purposes here, without digging really far deep into the content, let us just explore what these two monitors are so that you're prepared for them when that time does come. Back over here under the monitoring pane, let's take a look again at our RDSH session host role service, where we keep talking about this entity health monitor and then the 4 other monitors that exist here. All 5 of these are what we term aggregate roll-up monitors. And for each of the classes that are created, you'll find all 5 of these available by default. In fact, if I go to any other class, you will always find directly under that class, Entity Health, and below that, the 4 different sub-monitors there, those 4 aggregate roll-ups for availability, configuration, performance, and security. This is by default, and you'll find this with just about every class that you create and work with here in Operations Manager. These 4 are here really just as categories to help you divide out the different kinds of monitors as you take a look at them over there in the health monitoring pane, over there in the monitoring view. And really, as I said before, the definition of where these monitors go really has to do with whoever defines the monitors and adds them to whatever aggregate roll-up class exists. I say that you won't find yourself creating these all too often, at least at first, because in most situations, at least again, at first, in one of the 4 of these default classes. And so either it is an availability monitor or it's a configuration, performance, or security monitor. But that's not to say that those are the only aggregate roll-up monitors that you can create. Right here under our RDSH role service, we can create another aggregate roll-up monitor here and call it anything we want. Let's say here, for example, under our RDSH class, we wanted to create a new aggregate monitor called our best case scenario monitor. This monitor, again, would have another monitor target, just like we had. So I'd identify, once again, our RDS session host role service, like right down here. And then once I've done that, I need to choose a parent monitor for this roll-up monitor. It could be availability, configuration, performance, or security, or I could make it equal to those 4 default monitors. Once I configure this monitor and put it here into a management pack, this will then become the roll-up for any of the monitors that exist beneath this aggregate monitor there in the view. Now, by default, most of the monitors that you're working with that are in the management packs that you download will have the worst state of any member as the selection here for the health state. This means that any of the monitors below that aggregate roll-up monitor, if any of them turn to red, well, then the monitor itself turns to red and then sends that red value up the chain all the way to the very top. But if you have a situation where you don't want the worst state of any member to actually define the changing of that top level monitor, you can change that from worst state to best state. By changing this from worst to best state, what this means is that as long as just a single one of these monitors is green, well, it will bubble the green value up the chain as opposed to the red value. If you have certain monitors that you've configured where as long as one of them is green, everything is still just fine, well, then you can configure a new aggregate monitor here and choose it as a best state of any member monitor here. As before, I could generate alerts if I wanted to, or just create the monitor like what I'm doing so here. This will create, in addition to those 4 default aggregate roll-up monitors, a 5th that exists there, and it will provide another location where I could add additional monitors that I create right down here under the RDSH session host role service class right here. There currently aren't any monitors that exist here, but right now you can see that if there were, their state would be rolled up such that as long as any one of them is green, well then the monitor itself, the best case scenario monitor here, will also roll up as green. I can see how this looks back over here under monitoring. If I go back to my RDSH servers view right here, and once again take a look at the picture of health. So here under my Health Explorer, I'll take another look here at the entity health, and if I unfilter the monitors, right there is the aggregate roll-up monitor that I've created. There are no monitors underneath this, so it will just be a round green circle here until another monitor exists. But this is the way in which you can use one of these aggregate monitors in the case where you're creating your own unit monitors and need a slightly different way to roll up that picture of health. Now, of these, there is also another monitor type called a dependency roll-up monitor, which actually, if I minimize this, I can show you that back here under authoring, I can also go about creating one of these dependency roll-up monitors as well. And these are actually quite a bit more difficult to really comprehend because In order to really use these, you have to understand what the relationship is between different classes. If a class is contained by another class, you can use a dependency rollup monitor to roll up the status of health in the lower class to the upper level class. I'll show you here that if I right-click on monitors and choose to create a dependency rollup monitor, it's here where I can identify what the monitor target would be, and again, the parent monitor here. So for example, a dependency rollup monitor here is the name, the monitor target once again being right down here, the remote desktop services session host role service, and there. And if I hit OK and change the parent monitor here to, again, entity health, this would allow me to then create that dependency rollup monitor here in my RDS servers management pack. The big difference here is that you do need to have that existing relationship between classes for these dependency rollups to exist, or really for them to work. And we don't actually have a relationship here between this and another related class type. So we're not going to see much here in terms of what we can associate to actually get a lot of information out of the creation of these monitors. You'll find yourself actually using these more so when you're creating your own classes there, when you start digging much deeper into the XML to author your own management packs. The biggest difference here is that the creation of a dependency rollup monitor allows not only for the worst or best state of any member, but the worst state of a specified percentage of members as well. And so if you have a large number of, I don't know, DNS servers out there, where as long as most of them are operational, you're still actually servicing DNS requests, you can use this, for example, as a mechanism to set a percentage value to determine how many members need to be in a good state for this monitor not to actually experience a problem. So this is admittedly a very light introduction to the use of aggregate and dependency rollup monitors. For the most part, I'd just be aware that they're available here and that you can bring them to bear when you start having some pretty intricate requirements for how different classes interact with each other. And in fact, I'll actually show you an example of how a dependency rollup monitor can be used in the module coming up as we start building our own distributed applications and associating dependencies between the different objects that make up a much larger system. Even at nearly an hour of content here in this module, we really only barely scratched the surface of the different use cases and reasons for the creation of monitors and rules. We haven't even dug into the intricate XML requirements should you need to then further customize these in the creation of your own management packs. But what have we talked about in this module? We've gone through what is really an introduction into some of the basic use cases if you do have the need to monitor certain services or performance values or event log entries. We started there by taking a look at the differences between monitors and rules and why you might use one over the other. I also showed you that really useful trick for viewing the membership of a particular class or target, which really becomes handy when you start needing to craft up these monitors and rules. From there, we went into 4 different examples that try to span the different kinds of use cases you're likely to need at this point in your operations manager exploration. We took a look at it creating an event collection rule as well as a performance rule to populate our views with information about stuff in the event log and stuff in perfmon. We also then created a couple of monitors, one for determining whether a service was operational or not, and another to define a threshold for when performance is no longer healthy. We also looked very quickly there at some of the diagnostic and recovery tasks that you can configure for a monitor, and spent a very quick look there at aggregate and dependency rollup monitors, which are special use cases when you have the need to either join classes together or redefine the rules for what gets bubbled up. Coming up next, we finally put all these pieces together to create a distributed application. It's finally at this point where we can take all the monitoring that we've configured and assemble it together to create that diagram so we can understand the total picture of health for an application that spreads across multiple servers and services. In that next module, we'll talk about the creation of a distributed application. We'll actually create one for our RDS servers so we can see the dependencies between all the different objects that make up that entire infrastructure and get a feel for what we actually get when we start assembling together the entirety of this monitoring that we have with Operations Manager. That conversation on the configuration and use of distributed applications is a topic for our next module coming up. 8 modules into this course on monitoring Windows Server 2016 with Ops Manager, and we finally get to what I keep referring to as the capstone content. Now, don't get overwhelmed by the notion that I keep calling this capstone. The reality is that if you've done all the work that we have done here until this point, the actual creation of a distributed application is a relatively trivial thing to do. There is some art there in terms of how you actually create your distributed application. But the reality is if you've already gone through and created the kinds of monitoring that we've done here up until this point in the course, the actual configuration is little more than clicking and dragging. Here in this module, we'll go through understanding what a distributed application is. We'll also configure one for the RDS environment we've been working with here so far. And the reality is that because we already have configured all the different health models, because we've built in all the integrations to the different pieces of the environment we're working with, those RDS services, the individual machines themselves, and everything else in between, the actual configuration here of the distributed application is really little more than dragging a set of icons into a workspace and then connecting them together. Here in this module, I want to start first by showing you what the result of an already configured distributed application is. We'll start first by taking a look at the pair of DAs that are already there in the environment, one for Active Directory and one then also for our Ops Manager servers and services. These were created by the installation of the management pack for these different services, and so they give us a good feel for what the result will be after we go through configuring our custom one here for this RDS environment we'll then take a look at. There are a set of templates, I think 5 or so templates that you can use to begin the creation of a distributed application. These templates provide a starting point for helping you actually drag those icons there into that workspace. That said, though, although there are these 5 or so different templates that exist, the one that you'll find yourself probably using more so than any of the other ones is the blank template. And in fact, we'll use that as the starting point for creating this remote desktop services representation here for the different servers and services that make up our RDS environment. And so we'll create that distributed application here in the third topic in this module. Once we've done that, once we've actually identified which objects we're interested in and also then created the relationships between those objects, we'll then take a look at the fruits of our labor in exploring now the diagram view and also the Health Explorer view, which ultimately takes all the different green versus red representations of health and creates a single tree structure to give you more or less a single red versus green representation of that total, literal distributed application. Our whole goal here is to generate, as I said, that single representation so that we know when something has gone wrong with the services that we're working with, and then have the abilities to then bubble down, just like what we've already been doing here in the other Health Explorer views, down into the individual reasons why our, in this case, RDS application may not be performing to specifications. We do have one final task here, which actually is a bug in the blank template that we need to resolve. This bug exists because Microsoft did not fix the bug and hasn't in several versions now, I think all the way back since Ops Manager 2007. They haven't actually fixed the bug here because changing the blank template might impact other people's existing distributed applications. And so I'll show you one, it's actually a very quick fix here, that will ensure that all 4 of those major aggregate rollups will end up in the representation of health there in Health Explorer after you go about then configuring your distributed application. Now, back over here on my desktop, we have so far been spending quite a bit of time with the state views here inside of our operations console. These are the views here, if I hit F5, that show us the health, or the statement of health for each individual component, like our RDCB server or our RDS web server and so on. And we haven't really spent much time, though, in the diagram views, in part because the diagram view for an individual object doesn't really give us a lot of information that we don't already have as part of the Health Explorer view. And at least personally, I tend to find the Health Explorer view is a little easier to navigate around because of all these different objects, these different visualizations that are here in the diagram view. For this individual object, you can see RDCB has now split up its healthy and not monitor objects. And if I click down here, I can see the individual objects that then relate to this server RDCB. And as I said, this more or less is another slightly different representation of what we already see there in Health Explorer. Things, however, start to get a bit more interesting when we move away from individual objects and then over to distributed applications. Let me click over here under distributed applications and take a look at the two that already exist here in the environment. The first is our Ops Manager management group right here. The second is our Active Directory topology root, which was added through those Active Directory oriented management packs that we installed earlier on here in this course. I do want to show you that depending on how the individual who coded this actually codes it, you're going to get a very different representation of the objects that exist here in this distributed application. So for example, here for our Ops Manager group, if I take a look at the diagram view, I actually get one that looks very similar to the individual server view there for RDCB. So my healthy monitors and my not monitored monitors. But if I scroll down, you can see that the objects beneath this in the tree have actually been split up into the alphabet, mostly because there are so many objects underneath this here in this particular tree. So A through D, I through M, and M through W represents just a simple separation of those objects that exist underneath. Right down here, I can see now the all management servers group, the ACS representation, the data access service, and then the databases. And if I go one more level deep, I can see those two databases that are here for our Ops Manager environment, the Data Warehousing and Operations database. Although the initial representation looks a lot like the individual RDCB representation, you can see here that these things are actually very different objects. So I've got databases here, I've got services here. If I go here to I over M or I through M, I've got management configuration items here, infrastructure groups, and actually individual objects as well. So MGMT, another computer-oriented object here for MGMT. These distributed applications allow me to collect these otherwise unrelated objects and then also their monitoring and statements of health to create this whole bubbling up effect, where as long as everything is green, the top item here for Operations Manager itself exists as green. And if I right-click on that and choose Health Explorer, what I get then is a representation of our health here, if I unfilter the monitors, for everything that relates to my Operations Manager environment. Right here is availability and all the objects that exist underneath. Now, this is only one representation. Let me show you the other representation here for our Active Directory topology root, which will look quite a bit different in terms of how it actually is represented here on the screen. And this has everything to do with whoever wrote this, who created this management pack, how they actually built that distributed application. For here, the application is the Active Directory application, and there's my domain, company.pri. Down below that is another representation of the domain here, the domain controllers, and the site name and the site links as well. So depending on, again, how this person created this is how you're going to end up seeing this representation here in the diagram view. This will make more sense as you go through creating your own because you'll have a better familiarity for why you created that distributed application in the way that you did. So for right now, recognize that this is somebody else's representation of the health of your Active Directory. And it's really only when you start creating your own that you'll have a better understanding for how and why these different objects connect with each other. It is worth mentioning, though, that when we're looking at these different views here, you can go to really any level here in the tree and view then the health status of that level in the tree. So if I right-click here and choose Health Explorer on this object, I get the health of that object and that object alone. If I go further up in the tree, so all the way here to the top, I will get the total representation of health for that object and then everything beneath. So here I can use this as a mechanism to drill down to those specific items there among all these different otherwise unrelated things to figure out why Active Directory may be misbehaving. If you then take this understanding and then project it into the otherwise unrelated things that make up, for example, our RDS environment, you can really see the power of collecting all these different objects together. In creating our own custom distributed applications then, let's start this process first by closing down this and also closing down this. And then over here in the authoring view, take a look at the different templates that exist for creating our own distributed application. Let me now create this new distributed application. We can call this, I don't know, we'll call this just test for now. And right down here are the 5 example templates that exist. We're not going to create any out of these other templates, but I just want to show you what these templates are and how they kind of start the process here. You can see that we actually have an RD session host collection template that if I create it here, and I'm not going to go about creating it for real, But if I create it here, it shows me just some objects that have been associated together to create the relationships. Here at the top level are our RD session host servers, and then beneath that are dependencies then on our connection brokers and network devices, the domain controller, and the licensing server. I don't actually want to do this because my personal representation of the health of my RDS environment includes different objects than what I see here. So although this is a great example to start, it's perhaps not one that I want to use in creating my own personal representation. Let's run another test here and take a look at the .NET 3-tier application, which, if you're familiar with 3-tier applications, you know this is the database, the logic tier, and the presentation tier, which, as you can see right here, is represented by the data tier, typically a SQL Server or other database, your business logic tier here, which is usually your middleware, and then your presentation tier, which is often a web server. We also have up here the client perspective, which is actually a way in which you can install agents on individual desktop machines and use them and their perspective as a way to test how successful your application is. We will talk more about the client perspective and the installation of those agents on desktops as we get into the next course there on web applications and the integration with Azure. But again, this should give you another representation here of exactly how we might set up these relationships between a web server, which requires a business logic server or a middleware server, and you could get absolutely ridiculous with how deep you end up going with these diagrams that you create. One of the bits of the art here is in figuring out exactly how far you should go, and perhaps not going too far in creating the distributed application that makes sense for your environment. Let us then create our own distributed application here for our RDS servers, for that whole RDS environment we've been working with. And let's do so using the blank template so that we can begin with an empty sheet of paper. I'll start that process here by right-clicking and choosing to, again, create a new distributed application. And for this, you tend to name these whatever the name is for the entire service. For this, I'll call it our RDS environment, for example. And for that, I will use the blank template here. It's called Advanced, but I tend to use this for all the different DAs that I'm creating. And as with everything, we'll store it here in our DEN RDS servers management pack. And you can see we now have that empty blank sheet of paper for creating this. Let me just scroll this down here and start this process by adding then in the components that we then want to include in this logical diagram we're creating. It's right here where things get just a bit difficult because this is really the only representation, at least that I'm aware of, here in the graphical user interface, where you can start to see the relationship between objects and how they are then contained by other objects. I'll start this process here by calling it RDSH, so our remote desktop session host servers. And right here, recall in that last module, I told you that all the objects eventually bubble up to a single class that we call object. And then from there, we bubble down into the other classes that contain other information and instances of that information that we're looking for. As I said, things start to get complicated here because this list is extremely deep. You'll find yourself digging through all these different objects quite a bit to try to find out exactly what you're looking for. And to be perfectly frank, you will want to spend some time here in really just digging around to see what exactly you have access to. I will tell you that the vast majority of what you'll be looking for can be found here under Object, Configuration Item, and then Logical Entity. Here under Logical Entity will be the logical entities for the different instances of information that you're looking for. The classes of data that we've been working with here are nearly always included here in this logical entity class. And so for our RDSH servers, what we're looking for is in fact not found in the location where you might expect it to be. Let me show you actually one of the wrong places to look for RDS-oriented information. Here under Logical Entity, if I go down here to Computer Role, and then under Computer Role, Windows Computer Role, and then Remote Desktop Services Computer Role, right here are a couple of objects that relate to Remote Desktop Services. But in this case, these actually are the old representations from prior OS versions for RDS. And so I show you this because you can actually get distracted in all the different classes that exist, and some of these classes relate to older versions of MPs that are also included here in the MPs we've downloaded. We've downloaded, obviously, those for Windows Server 2016, but they themselves rely on older versions of the MPs that can include some sometimes confusing additional classes that may or may not contain the right information. For our RDS servers, what we are looking for here is actually found under Application Component. And here, there, again, under Windows Application Component and Remote Desktop Services Generic Role Service. You may recall that these are the actual names here of the classes that we worked with back in that last module as we were creating our own custom monitors and those RDS-related classes. We were working quite a bit here with the Remote Desktop Session Host Role Service class right here. And I just happen to know that that includes the information, the instance of the information that we need. So here is rdsh.company.pri. Let me then add in the other components we also require. So our RD web component, which right down here will include logical entity, application components, Windows application component, again, remote desktop services, and then the remote desktop services web access role service here. I also then need to add in addition to this, the connection broker, so RDCB. Right down here, if I scroll down once again, logical, application component, Windows application component, and then right here will be the remote desktop connection broker role service. These are the three main components of the RDS environment we've been working with here so far, and each includes a single server, RDCB, RDSH, and then right here, RDS web. In an environment where you have multiple different servers, you can imagine that there will actually be multiple different servers in these classes that you're working with, and you will have seen them already if you've been working with the classes through the other examples here in this course. But here we only have a single server in each class, so we can very simply just drag that server over here, right here to the class representation here in the workspace. So this is RDS web, our RDSH server is right here, and then our remote desktop connection broker server will be down here. And I can drag these around really in the workspace to try to identify exactly how I want them to be visualized. This process of figuring out which classes you're looking for and which then instances belong in the classes that you're creating is entirely an art form. You will probably poke around with this for quite a bit until you find exactly the configuration that makes sense for your particular implementation. Let's say, however, that in my environment, what is of most importance is the service itself, so the RDSH server that hosts the applications. In this environment, this RDSH server requires or relies on a connection broker for it to do its job. If the connection broker isn't working, well, users can't connect to the RDSH server. So in order to represent that dependency, I can create a relationship here that starts at RDSH and goes to RDCB. My RDSH servers also require a dependency on RDS web. If the RDS web service is also not available, well, users can't connect to their applications. So I have a further relationship here between RDSH and RD web. You could use these relationships to now figure out, well, what else do I want to include here that this representation of the service, this RDSH server, is actually reliant upon? What else might we have? Well, we have a website, and then we actually have the computer objects themselves. So let's add in those here into our model as well. Let me add in another component here. So we'll call this IIS. And right down here, we will add in, once again, logical entity, application component, and then here's website, an IIS website, an IIS-10 website. And here on that IIS-10 website, you can see the two instances of websites that are being collected by our Ops Manager environment. One for our management server, this is our Ops Manager server, and then our RDS web server here. I don't want to include the management server in here because my RDS environment and my Ops Manager environment aren't necessarily reliant on each other. But this RDS website is reliant, or perhaps the other way around, the web access service is reliant then on IIS and then the website. If the website goes down, well then RD web can't do its job. So let's create a further relationship here between RD web and IIS. So now I know that if the website goes down, RD web goes down, and if RD web goes down, then nobody can connect to RDSH. There is also a further relationship that I could configure, which has to do with the individual computer objects. If you recall, when we took a look at all the instances that exist here in these role services, they were very focused exclusively on the functioning of the role service. But if I have problems with, I don't know, too much memory use or too much disk use, those are not going to be represented here in this statement of health. I need to include more objects here so that if I have those very core issues with the server itself, well then those get rolled up into the health statement for our total RDS environment. Let's add that representation in here as well. So let me add in yet one more component here, which I will just call the computers, or perhaps the Windows servers. Down here under objects of the following type, let's go once again to logical entity, but rather than going to those individual application components, let's take a look at device here, and then computer, and Windows Server, so that we can see for our Windows Server 2016 computer, right here is a representation then of the most core, the most foundational metrics that exist there for any Windows Server 2016 computer. And so if I hit OK here, you'll see that all the different Windows Server 2016 computers will exist here as instances here in this list. Now I'm going to make a dependency here between RDSH and the computers, although you may not necessarily make this configuration. You might want a single relationship between each of the roles and their computer instances, but just to make things easy here, let's actually put all the computers in here as a dependency on our RDSH server. So let's plug in here RDCB, our RDSH machine right there, and then RDS Web. We now have, if I relay this out, a representation of the distributed application that we're working with. And really, all we're doing is connecting together all those different rules and monitors for the individual classes that we've been working with all the way up until this point here in this course. I should, if I save things here, be able now to take a look at this back over in our monitoring pane to see exactly what now we've created. Let's take a look then at the fruits of our labor. So let me now close this down. We've already saved it. And then back over here on the monitoring pane and come over here to distributed applications and refresh the screen to see exactly now what we have here in our RDS environment. This process takes a minute or two because there is that same set of background processes that Ops Manager needs to do. But if I open up the diagram view, I should now see a view that kind of looks more like what I saw for Active Directory, but now related to RDS. You can see the error message here because we do have a lot of objects that need to be rendered, but what we get right here is a nice view that shows me for my RDS environment, here are the relationships between the computers, IIS, those individual default websites, and then the subsites to those sites. Here's my RDCB server and the objects that exist beneath RDCB. Here's RDSH and those objects as well, and then RDWeb. And for any of these, I can now go to Health Explorer and see the individual monitors that exist in that object or for that object and for that class. These are, as we saw before, related to RD Session Host. So here are all the monitors that we have, including right here the custom monitor that we configured back in that last module. We even have that custom aggregate rollup that we configured as well. There's our best case scenario rollup module that doesn't have any real monitors underneath it. But this essentially, as I said, allows you to take all these individual objects and just roll together their entire statement and picture of health. If I then hit F5 here to then refresh the model, after a period of time, I should then see, yep, right here I have the same green check like what I should expect to see for all the different individual objects that I'm working with. And if at any point any of these objects end up failing, so if a server goes down or a service goes down or anything that I'm monitoring has an issue that goes beyond its behavioral threshold, well, this will now let me know from a single view that the RDS environment I'm charged with managing is having a problem today. Now, one thing I will tell you is that this whole environment here sometimes can just get a bit choked up with all the different monitors that exist. If I right-click here and choose Health Explorer, it's going to take me a while to filter out all these monitors. You can see now why the monitor filtering is enabled by default, because you don't want to have to dig through all these individual monitors that exist down here. There will be a lot of them, so all contained objects, and then all the availability objects here for each of the servers we're working with. This is why, for the most part, you really only focus on these when there is a monitor that's gone from green to red. You don't care about all the green monitors because there are all these different monitors that exist here in the system. But for the most part, this should give you a good feel for how I can take all these different monitors and collect them together to get that single picture of health for this entire application. Now, the nice part about these distributed applications is that you can actually go back and just rearrange the order and the list of dependencies between them, and it will be then almost immediately represented over here in monitoring. But one thing you should notice here in our use of that blank template is that we really only see availability metrics here for our RDS environment. If I go down to some of the sub-environments down here, so here's my RDSH and then the object below, if I look at Health Explorer here, well, then I have a really good representation of all the different health objects that exist. But at the top level, actually, I've got a bit of a problem here in that I'm only seeing just the top level object for our availability metrics, but not the other three. This has nothing to do with what you've configured. There actually is a bug, a long-standing bug here in this blank template that disallows configuration, performance, and security metrics to exist here by default. And so we actually have to go through kind of hacking this blank template just a bit so that we can see all the different objects that exist here for the other three aggregate roll-ups. Let me minimize this, and let's also get rid of this and come back here to our authoring pane, and I will show you the very simple way in which you can now make these available. Well, let's come back here, and in fact, not under the distributed application, but rather over here under the monitors. And let us now filter by the actual distributed application, which itself is now also a class, or technically really a target here. This DEN RDS server's target is one that we can now take a look at, and as before, we have the same entity health and availability, configuration, performance, and security. And in fact, that's not what I'm looking for. It's not DEN RDS servers, but rather our, right here, our RDS environment. So this RDS environment here, this includes availability, configuration, performance, and security monitors. And you can see the all contained objects. This is the dependency roll-up that exists here underneath availability. The bug actually is because this all contained objects dependency rollup actually never got added here to configuration, performance, and security. And so the only thing you really have to do here is to create this dependency rollup monitor. I know I kind of punted over here to this module from the previous one on dependency rollup monitors, in part because they are kind of difficult to understand until you kind of see how all these different pieces can integrate with each other. Let us now create a new dependency rollup monitor called all contained objects for each of the three that's actually missing it here in this list. The first one here is for configuration, and the monitor will be enabled. We do want to target it to our RDS environment here. And what we're looking for is the bottom object membership, entity health, and then whichever one we're looking for. So in this case, configuration. This will then create that dependency monitor, which will allow the membership of object to roll up all those contained items, so all the contained instances here into this picture of health. And so we know this because we can look at the properties of the one that's actually correctly configured, but let's go ahead and configure this for configuration and then also for performance and security as well. The configuration on this screen for the one that actually is correctly configured is worst state of any member, and then the same default configuration down here at the bottom. So I'll choose next down here, and then I won't actually generate any alerts for the monitor because those alerts will be generated from their own down level monitors. I don't want to create multiple duplicate alerts whenever a problem occurs. And so this is the first of the three that we need to configure. We then need to configure the second and third of the three as well. Which if I fast forward things here just a bit, so that you don't actually have to see me repeat those exact same steps 2 more times, you can see now that we have all contained objects here for all 4 of these: configuration, performance, security, and availability. Again, just for clarity here, you're really just mirroring what you see here in the configuration of all contained objects for the one that actually works. Notice here the bottom object membership with its representation here of the availability rollup monitor. So we're essentially just repeating this process using the same health rollup policy configuration and the same alerting configuration, which does not generate an alert. It is worth mentioning that you do want to be careful not to create multiple alerts because you might find yourself confused when the actual monitor alerts and then the rollup monitor alerts as well. Once we've done that, and we have all 4 of these all-contained objects that exist here in the authoring pane, we should, after a minute or so, be able to go back here to our distributed applications back in the monitoring view, and then take a look once again at our Health Explorer for the top-level view. If I unfilter the monitors one more time, we should be able to see actually that we now have the drill down for all 4 of these roll-up monitors that will exist here in the list. Right here we can see now configuration, performance, and security. And if I drill down to all contained objects, well, there are all the security-oriented contained objects for the distributed application that I've configured. You can now make this available to your users, so give them access to the distributed application so that they can keep better tabs on the environments they're charged with managing. I really do just love these distributed applications because they really are the capstone of everything we are attempting to accomplish here throughout the course. Once I understand how the monitors work, once I understand how they roll up into individual objects, well, then I can then take that information and collect together the distributed set of objects to create a single representation of health. What have we talked about in this module? We've talked about exactly how to create that single green versus red representation. We started first by looking at those diagram and state views for the individual objects as well as the default distributed applications that exist here in the environment, those that are added for us by virtue of downloading and installing certain management packs. We looked at the 5 or so templates that exist there out of the box and then actually created a DA here for our RDS environment using that blank template. It is worth mentioning again that the activity in creating these DAs will be an iterative one. You'll decide that perhaps you want to move some boxes around from time to time as you really try to figure out what depends on what, and what actually depends on what is entirely your purview for figuring it out. Once we created the one here for our RDS environment, we then looked at what we actually created. We explored the diagram and also how Health Explorer is now altered to see the very long list of monitors for representing the health of the service. And then concluded there with fixing that minor bug that exists in that blank template. It may also exist in some of the other templates as well, but essentially just creating that dependency roll-up monitor that gives you access to all of the aggregate monitors for the distributed application that you're configuring. And with that, we bring to a close this course on monitoring Windows Server 2016, as well as the services and applications that exist on top using Operations Manager 2016. Coming up next, we have an entirely new course, this time focusing our attentions away from the core foundations of Windows Server 2016 and just a bit further up into the stack of applications and services that make up the actual things we're delivering to our users. In that fourth and final course here in this learning path, we'll explore the ways in which you can use Operations Manager to monitor your web applications and dig deeply into the individual transactions that occur when users interact then with your web servers and your web applications. There also we'll extend our monitoring vision into the resources that you have hosted there in the Microsoft Azure cloud. In that course, you'll get a feel for the other management packs and approaches that you can bring to bear when you have resources spread across your local data center, as well as those that exist in a remote data center hosted in Azure. That conversation on monitoring your web applications as well as your Azure resources is the topic for our next course coming up.